Hello everyone. Since Droidcon Italy was launched in 2014 by Synesthesia, the hackathon has been an important part of the event. Of course, since then hackathons have become a lot more well-known and are more familiar in the market, but we still think they are an important way to explore new ideas, build teams, and learn new skills in a really hands-on way. This year we had a great pleasure to work with Intel, Cisco, ETSI, Lynx, GSMA, Turin City, Team, Equinix, and Edge Computing World. So welcome again to the hackathon. And as we say, we are pleased to welcome all the teams selected to the hackathon. And we'd like to introduce the theme of the hackathon. So the technical challenge. MEC, multi-access edge computing, can serve many key 5G use cases. So most of them are related to application scenario, specifically targeted to vertical markets of the 5G era. So the purpose of the hackathon is to demonstrate the usage of MEC system, an enabler for different use cases of business objectives. So helping all the stakeholders to develop a diverse, open MEC ecosystem. For example, we can use MEC in automotive, factories of theater, drones, consumer media, and entertainment. I would like to say too that this is a fully remote edition. So all the teams are planning to work remotely. So they will present their jobs on tomorrow, and the competition will end on tomorrow evening. And then there will be the prize giving of the hackathon during the Droidcon in Friday evening. So I would like to leave to Dario Sabella of Intel words. And Dario, you can
hello everybody.
Explain the technical challenge.
Thanks, Francesco. Thanks for hosting this event. I'm so excited to be part of this organizing committee. Thanks also for the Synesthesia to organize everything here, and on behalf of Intel, but also on the other companies, I would like to thank all the committee for their great effort in organizing this event and this hackathon competition. So here you can see technically the challenge for the developers. We would like really to invite application developers to use edge computing. This is a quite a new technology, but also very promising. So it's worth learning something, and we hope we'll do a sort of service for developers in these 2 days in parallel to the competition. That's why we organize these tutorials as well. And this is the technical challenge. You can see a lot of use cases and applications for your inspiration. Of course, all those things are made possible with the support of edge computing technology. And application developers are encouraged to design and develop their Android applications for MEC service, MEC-enabled 5G networks, running on openness platform and using ETSI MEC technologies. That's a very nice environment that we are providing for hackathon developers. And I also would like to emphasize that the organizing committee has decided to offer remote server access to up to 2 last-minute teams registering for remote participation. So this is really an opportunity for you to learn in practice with real commercial server, real stuff, platforms offered for free to you remotely. We can offer remote access to this complete end-to-end hardware and software environment. This is something that exception we decide to offer also for last-minute registrants. And you can see information. For further information, you can contact the official Droidcon email address to ask the access. Please do so if you are interested to seriously learn about MEC in parallel to these tutorials in these 2 days. And then let me introduce as well the jury members of this hackathon competition. Apart from myself, as well Alessandro Breccia from Cisco, Andrea Laganati, Telecom Italia Mobile, Maurizio Floridi, Links Foundation, Guido Quenders, Equinix, Michele Carignani from ETSI, Tom Van Pelt, GSMA, Nicola Faronato from Turin City, Francesco, you from Synesthesia. And thanks also everybody, all the members of the committee that are listed here, and many other people that permitted this event. So this is a very good committee, and I would like to thank you again for your nice collaboration and this great and successful event. So maybe something interesting for developers, and Francesco, we have designed a set of interesting prizes offered by the organizing committee. First of all, yes,
we as Synesthesia will provide for the winners, for the winning team, free passes for a future Droidcon conference. We hope that it will be a live conference, so they can come to Turin and see the live conference. And we will send to the winning team a trophy. It will be all the swag bag of the Droidcon 2020 edition with a t-shirt and a lot of stuff donated by the sponsors. So it will be the winning prize, another winning prize from Synesthesia. And
in addition, Intel will provide some nice possibility for the winner to be eligible to be part of Intel Software Innovation Program, and other things to come, also special prizes offered to the committee if they are willing to use and exploit OpenVINO Toolkit, DPC++ framework, other interesting toolkits that we are offering in the platform. Let me also mention, Francesco, this is a nice offering also from the Turin City that is also having this patronage of this event. The winners will be offered the possibility to participate to the Smart Road project, a consortium of partners from car makers, network operators, university, and the city of Turin itself, with the aim of proposing their developed solution as a possible implementation for testing activities in the urban environment in Turin. So that's also a nice opportunity complementing the nice set of prizes. But let's not discover all our cards, maybe some other surprise on stage for the celebration day, okay? So let us, please guys, let's have a look to the agenda. We are organizing a full agenda of many talks and contributions and keynote and workshop sessions divided in 2 days. Day 1 is today, but the overall organization is divided in 2 tracks. The track number 1 is the present one, the public one event, and the track number 2 is dedicated to developers with the organizing committee, with a private chat and environment for them to get in contact with our experts and to learn better in case of technical questions. So there will be, first of all, Michele Carignani from ETSI CTI introducing ETSI MEC architecture and open API work in the Forge open source implementation. Overview on the MEC Hackathon setup from Anish and Xavier from Intel, a deep dive in the afternoon on openness, platform, and then hands-on session with one API toolkit, and then a nice talk and inspiring keynote for developers, startup, and innovators ecosystem in the 5G era from Techstars, and of course the entire event will be live streaming for both days. and we are planning also to publish the link for offline watching, especially for people that cannot see it live. We have also second day. The second day, please notice that the links, the WebEx links will be different. So you go in the agenda, you click it, you link, and there will be this a web event for the second day. Again, track number 1 with a lot of speakers from Cisco, Edge Computing View, and then some description of the MEC implementation of allocation API from Links Foundation, and then Masaki Suzuki from KDDI as a rapporteur with the MEC work item on MEC Federation will provide a nice talk. And then in the afternoon we will have the City of Turin with Nicola Faronato giving an introductory talk, also mentioning Smart Road project in Torino, and Edge Computing implementation, the telco viewpoint from Team. And we will have GSMA with operator platform introduction, and a talk from Leonardo Gomez from Intel, and also representing 5G AA, MEC for auto activities on Edge Computing for automotive. And then Juan Carlos Garcia Lopez from Telefonica will talk about Telco Edge Cloud Task Force, and finally Himanshu Singh from Altran MEC Federation Solution. And then I will have the pleasure to moderate a set of keynote speakers and panelists, and the final panel discussion on business opportunities offered by Edge Cloud for the automotive and other industry segments. So at the end, we will be at the very end of these 2-day events for the hackathon. Francesco, you will be closing the event, and we will invite people to have a look to the final day, the day of, for the prize giving on 27 afternoon, where will be announced the winner. So yeah, so let's wait for this final panel discussion. I hope will be very inspiring and insightful. What you say for developers now? This is more interesting information for developers and some guideline for the delivery of their project. According to the agenda, we have an intermediate delivery today at the afternoon, 5 p.m. Where there will be also an elevator pitch to the committee, to the organizing committee. They are expected to deliver their documentation and also some supporting material. And of course, there will be an area, a private area, where they can upload all the material. Okay, so please consider using this area as a convenient place to put everything you feel is important to raise, let's say, the attention on your project, and maybe some video clip, other demo docs, and everything you think is suitable and nice. And then there will be, of course, an elevator pitch, only private for the committee, but just very short, 3 minutes at maximum for each team. And then for the first intermediate delivery today, tomorrow there will be the final delivery at 5 p.m. And then the jury will evaluate and we do their consideration about the evaluation of the hackathon. And then, of course, we'll use all the material that will be uploaded and updated for the final delivery. So I think I said everything, but please, Francesco, feel free to correct me. There will be the celebration at the end on 27 November in the main conference, the main Droidcon conference that will start in 2 days from now.
Yes, I can confirm it. And everyone is invited. It will be public and published on YouTube Droidcon channel 2. So it will be not only for the attendees of the Droidcon event, but for everyone that is following our YouTube channel.
Fantastic. So, cool. So yeah, let's start now. I think we have plenty of things to to do now, and a nice set of talks in the agenda. Okay, so let's start the hackathon. For the guys and developers, enjoy the coding, and also guys, stay here connected in track 1 for the live streaming and follow all the tutorials. I think it will be interesting for everybody. So thank you so much.
Thank you, Dario.
Maybe now it's time to move to the first talk from Michele Carignani from ETSI CTI. Go, Michele. The floor is yours. You can go.
Okay. Hello, everybody. Good morning. Thank you very much for the invitation. My name is Michele Carignani. I'm part of ETSI staff. And first of all, let me say that I'm really thankful and honored to be starting this session today and introducing the ETSI MEC technologies and how they can help developers in their challenge to deploying their applications on the edge. So I've prepared a few slides because the task is quite wide, and I wanted to put the things on the perspective of the developers, but also to give you some pointers, to give anybody some pointers to get involved in this journey and to get involved in the community of ETSI MEC ISG. So first of all, a few words about ETSI, the European Telecommunication Standards Institute. We are part of the staff for a large organization which has more than 900 organizations globally, and serves to define specifications and technologies to serve both normative and also industry-wide association. And myself, I'm actually part of a team within the ETSI staff, which is called the Center for Testing and Interoperability. And our task is pretty much fun. We actually try to put things together, to take the pieces of what has been specified and standardized, to put them together, to bundle it together with the companies that are implementing the products, and to see what breaks so we can improve and always deliver the best quality of standards possible. So let's move then to the to introducing ETSI MEC. And from the perspective of a developer, you of course know well the development of applications for devices, mobile phones, cars, IoT, and you of course may know the development for applications in the cloud. Well, ETSI MEC targets the edge, which plays somewhere in between the two. And of course, this can be a very large definition. And this can be on top of an antenna, on a mountain. This could be within a metropolitan city. This could be anywhere. And if you have implemented an application meant to be deployed at the edge, the application may ask itself some questions, in fact. First of all, how do I reach my cloud service? So how am I connected to the internet, to the backbone network? And which instance, for example, in my cloud or in my private or public cloud should I target? How do I get discovered by my users? Right? But actually, it really can ask itself, where am I? Am I really on the top of a mountain? Am I really near a town? Am I really on the roadside? And what is it around me? How am I connected to my users? Which type of quality of service the network I'm working on is offering to my users and to my application? And moreover, how many users am I serving and where are they? right? These are all information which are relevant in order to provide the service, to provide an application which has really an impact, maybe a real-time impact on the users. And moreover, how can I be sure that I'm running when and where they need me, right? I'm probably not running all the time. I'm not running everywhere. So how can I be there when the users need me? And what if my users move? What if they pass on to the next cellular mobile tower, or they pass over to the next point of presence that my organization is offering? So these are questions that become really interesting when we talk about edge computing, because they span for really a large set of scenarios and use cases. So ETSI MEC tries to provide an answer to all these questions in an aggregated way, in an interoperable and portable way. And this is done through the introduction of what we call the MEC platform. The MEC platform is a component that runs on the MEC host, so it runs at the edge level. It runs close to the MEC application itself and offers a set of capabilities to the MEC application. Okay, in particular, it offers some services, and these services are exposed to the application through a set of APIs. But we will get more on this. Now, under the hood, this is a bit more complex. So this is the architecture of the MEC technologies as specified by the ETSI industry group. And as you see, we have quite a few components, right, with respect to the previous slide. And this is what is needed in order to support, to provide the infrastructure for all this to work. And I try to highlight with colors the different parts of these systems or these subsystems. So we have a blue part, which is about orchestration, which is about managing the whole system, deciding which application can go on the network and which application should not. The other part is about management, about making sure that all the components are installed and active in the locations that have been managed, and all the infrastructure is available. The green part is about virtualization, because this is an enabling platform for the running applications in different contexts. And possibly we have the red part, which is other MEC platforms, other MEC systems, and how to interact with different locations at the same time. Now, the components we have seen before, they play in different parts. So the device app, actually, what is running, for example, on an Android phone or an IoT device, is actually connected to the whole system, because it needs to discover the application and to interact with the whole system. While the MEC application is running on the virtualization infrastructure and next to what we called already the MEC platform. This is specified in a document which is called ETSIGS MEC 003. And of course, these are all public standards, and these are all public specifications, and you can just Google them at any point in time, and hopefully you will find them pretty soon. So in order to gather and to manage all this complexity, at ETSI, a set of organizations, a set of companies have been creating an industry specification group, which is called ETSI ISG MEC. Now, ETSI is focused on telecommunications. It has a large history in, quite long history in mobile network developments, and also in other technologies and networks that have been applied all over the world. And in this context, there was the need to actually bring together a set of actors, vendors, operators, research institutes, public institutes as well, in order to address the edge computing. Now, when we talk about edge computing for telecommunications, it was historically what we call the mobile edge computing. So how to use the mobile network point of presence in the edge of the network to enable this. But it soon became the multi-access edge computing, because now, together with the evolution of the mobile networks, and in particular with 5G, we have really a multitude of points of presence, of connection points. And this could be through different technologies in different contexts. And therefore, the ISG MEC is targeting a multi-access network type of deployment. So, as I was saying, the goal of the industry specification group is to bring together very different companies, very different organizations around the world to understand what are the needs for interoperability and for portability, and to provide a set of specification, to provide the blueprints so that the companies can then offer services which actually are able to be deployed globally. And there were really quite a large number of organizations which are part of this group, and they're all bringing the requirements and the constraints coming from the different application domains, from the different regulative scenarios as well, and from the different backgrounds. So it is really a diverse community, and we hope that some of you may also be interested in joining this community and bring your interests and your goals for the edge computing and MEC at large. Now, in particular, for the developers, what is ETSI MEC offering so that the application at the edge can be successful? Well, mainly for the edge application development community, ETSI MEC is providing a unified and portable set of MEC APIs. In this way, as we have seen, the MEC app, so the components developed by the developers themselves, so when developing the cloud and edge application, the developers can know that whichever the type of deployments, whichever the application use case, the location, and whichever the actually infrastructure they're running on, they can find a set of services and they can query those services in a uniform way so that they can be portable and they can provide this service all over the world. So in particular, the MEC APIs, they enable the application in their locations to discover the network they are on, whether it's a mobile network, a Wi-Fi network, it's a vehicular network, to discover the users, the capabilities of the network that they have, and which other local services. Is there a video encoding services? Is there an encryption service or a distributed ledger service on the location? These are all information that are needed by the developers and by the app in order to make the best decision for the service it's offering. But moreover, the APIs manage also to unable to manage some of the network aspects, such as the traffic that is configured for the application, the capability of those traffic, the DNS, so the discovery of other services, mobility aspects, V2S aspects, and so on and so forth. And finally, what the API offer to the developers is also the possibility to create a third-party proprietary service, a new API that you may want to let available for other applications, and to register it in the platform so that other applications can discover your service, can consume, and therefore can enable a new type of applications and domains. Moreover, there are also a set of, well, let's say, internal APIs which are managed to create interoperability and portability among the MEC systems. These are less of interest for the developer or the applications, but are still relevant and important to understand how the MEC systems work in general and what they can offer to application developers. So let's have another look to the architecture as we have presented it before, and let's see actually where the APIs are trying to address their needs. So this may seem a bit messy, so let's try to clear up a little bit. Let's just remember we have a blue part, which is about orchestration, the yellow part about management, and the green part, which is the virtualization infrastructure. We leave here the parts which are relevant to the developers. So the device app, the part of the application which is running together with the user or close to the user, and then the MEC app, which is running in the edge together with the MEC platform. And actually, these are really just the thing that a developer should worry about, and the rest is actually provided by the infrastructure. And we can distinguish two groups of APIs as defined by ETSI MEC in this area. So the yellow ones the first box that we have are defined between the MEC app and the MEC platform. And we already have a set of APIs available, and more can be created, more will be created. So we have application support, anything which needs to be provided to the application to discover the environment, service management, so registering and discovering services in the location, the information about the radio network, the information about location of the users and the number of the users, the identity of the user equipment that are available in this access network, bandwidth management, fixed access network information, WLAN information, and V2X. Okay, so if you see, this tries to target very different application scenarios, and it's not meant for all the applications to consume all the APIs, but to select the API which is best for the use case it's trying to enable. And moreover, we have the blue arrows which interact with the system at large, let's say. And these are containing applications such as the application package life cycle management, so that how you package an application so it can be onboarded and deployed in all the locations by the system automatically. Operation granting, so how to request that some operations are actually enabled. And also the device application interface. So how can my application running on my device, my IoT or mobile phone devices, can request that in my point of presence, so close to me, in the antenna close to me, or in the access network close to me, I can request the activation of my own MEC application so it can leverage the power of the edge computing. Okay, so we will have more description of the APIs in particular, and we will of course be able to try and to use those API firsthand. But what I want to do in the rest of the presentation now is actually to give you some pointers on where you can find the documentation. And I'm going to start from what we call the ETSI Forge, which is a platform specially meant for developers to discover the standards and to discover the machine-readable standards. So a way for discovering the specification and to also automate directly on those. So with respect to ETSI MEC, a lot of effort has been put into providing the APIs together with the standards, also in the Open API format. So what we are offering to the developers is actually a GitLab installation where, powered by Git, we continuously update and improve those Open API definitions so that you can then use tooling to read the documentation, to generate client or server implementation, and so on and so forth. And this is all public and available on the ETSI Forge, and you're really invited to navigate to the platform and to discover it yourself. And as I was saying, this should be seen as complementary to the standard itself. So as I mentioned before, all ETSI standards are publicly available. They are released in PDF version, and you can Google them up at any point in time. In those standards, you will find the description of the service, the goal, the application scenarios, and everything which is more descriptive and informative about the service. And then together with that, you can use the machine-readable representation, in this case, the Open APIs, to really understand the data types, to really understand what is exchanged by the API and how to discover and consume these interfaces. So they're really meant to be complementary and used together. But this is not enough. Documentation is only a part of this discovery and adoption journey. And therefore, ETSI MEC is also providing testing facilities, and in particular, the framework and the implementation of a test suite for all the APIs, and in particular for the servers of those APIs. Because, of course, having a common blueprint is something, and it's the first step, and it's necessary in order to enable portability. But it is true that the products are going to be diverse, are going to be provided in very different situations. Therefore, in order to make sure that this portability and interoperability works, in reality, right, in the deployment in our application domains, we are also trying to provide, together with ETSI MEC, all the tooling to really assess this portability and interoperability. So the first tool is this set of test suites, which are specified in a standardized document. It's called MEC Deck 32. And they also come already with an implementation in two flavors, in the robot framework language and in the TTCN3 language, the test and test control notation. These are all available on the ETSI Forge. You will find them in the MEC group. And they're all released openly and freely for everybody under the BSD3 license. Moreover, you will want to try this, right? Okay, we have the specifications, we have the tests for the servers, but what if I want to try to connect to somebody? This is the goal of the MEC Ecosystem Wiki. It is a page on the MEC Wiki which collects all the implementations, open source projects or proprietary implementations, in order to give people some pointers of what is available and what can be tried, sometimes on the web, sometimes freely. Moreover, we have this opportunity of hackathons, which gives a much better integration opportunity and gives the expertise of the people who are working on the platforms to interact with. But we also want to grow an ecosystem so that people can confidently start using the MEC APIs and test them by themselves. Now, this page is an open page, so we really welcome anybody who wants to be added on this page. So if you are going to implement your own MEC app, feel free to reach out to cti support@etsi.org so that we can add an entry for your solution. And I'm really happy to announce this, and this is one of the first times that we actually discuss this publicly, but we are also working on a new project, which is called the MEC Sandbox. And this is meant to be the ultimate app development companion, because it is actually a simulation environment where we have a realistic scenario with 4G, 5G networks, and what could be those access points provided by those networks in, as I was saying, in the realistic scenario, together with the steady and moving user equipments, so devices such as pedestrians, such as vehicles and cameras, and an API console so that developers can really interact with this simulated environment and use the MEC APIs to understand and discover the features of these networks and of these APIs. So this is something that is going to come really soon, hopefully in the first quarter of 2021. So we really invite you, if you're interested, to stay tuned on the ETSI channels, and this will be published and promoted. Coming to a conclusion, I also wanted to mention another opportunity that we have for MEC application and MEC system developers in order to make sure that they bring solutions that are portable and interoperable on the market. And this is this is what we call the MECplugtests. These are actually events where, like hackathons, you can join and you can bring your expertise and your implementations. But the focus is not meant on the development on site or a development dedicated for the event. This is really for bringing the solutions that you want to make a product or that you want to bring to the market, and to have an environment where you can test it with different type of providers, different type of solutions, either proprietary or open source. And we are going to have 2 events in the MECplugtest program for next year. These are organized by ETSI, and they are free for everybody to participate and free of charge. We have first NAV and MEC API plug test, which is going to be focused on compliance to the APIs themselves, in particular API servers, and this is going to be in February 2021. And moreover, we are going to have what we hope is going to be a physical event later on in October 2021, where we can welcome anybody in ETSI headquarters in the south of France. And we are really looking forward to this possibility, and we hope for everybody that this is going to be a real opportunity. And in this event, really focus on interoperability about products, about solutions out there. So let me briefly mention the timeline if you want to participate in this, because if you find interest and if you find value in the MEC APIs and in developing MEC applications, we really want to make sure that you are aware of this opportunity. So as I was saying, we have two main events, one in February, which is going to be fully remote and dedicated on APIs, and another one in October, which hopefully is going to be face-to-face. And for the first event, registrations are currently open, so you're welcome to register or to get in contact with us if you're interested for that. So to conclude, my goal for today was to introduce you to the MEC systems and the MEC APIs. Hopefully you were already maybe somehow familiar with those, but also to show that there is a community behind that, and there is a community of people that are working in order to make the edge computing successful. And I really wish that you can somehow get involved in that. And we think we have several opportunities for any type of organization or developers. So first of all, go learn, implement the MEC APIs, and you find all the documentation on the forge.etsi.org. We welcome you to test, to experiment, and also to collaborate on those APIs, to report issues, bugs, which may always happen, and to stay tuned for the announcement of the MEC Sandbox. You are welcome to share your projects on the MEC wiki. So this could be your GitHub repository, this could be your company's product. To join the discussion on the social media, we are always welcoming feedback and actually input from the first-hand developers. To register the program of the NAV and MECplugtests, in case you're interested in really testing portability and interoperability of your solution. And finally, to join the ISG MEC, if you think that you can bring new ideas or new requirements to the design and standardization of MEC systems, or to participate in the ecosystem activities that we are developing together with ISG MEC. So with that, I hope I made it on time, and I thank you once again, all the organizers, for creating this event, for actually keeping up with this event in this very difficult situation that we are all living. And I wish that you can enjoy the hackathon, and I wish you best of luck for getting the prizes. Thank you all. So I guess I leave the floor back to Dario. Thank you, Dario.
Oh, thank you so very much, Michele, for your nice presentation. Yes, I think this was very useful to understand what is MEC technology from a standard perspective. The great work that you are leading in the city. Thank you so much again.
Thank you, and thank you again to all the organizers.
So, yeah, we have a next intervention overview of the MEC Hackathon setup for application developers, and the presentation was prepared by Anish Ravat and Xavier Simonart from Intel. Mirko, you as a host of the WebEx tool, do you would like to manage this, please, for us? Thank you.
Yes, sure. Let's just introduce himself, Anish, if you can.
Yeah, so hi everyone. This is Anish. I'm working in Intel Germany in the IoTG group. So today, me and Xavier is going to give you a short talk, a short session, which includes two parts. On the first part, we are going to tell about the hackathon setup, MEC setup, which we offer to the developers who are participating in this hackathon. And in the second, we have a short demo video. It's basically telling what were the actual steps we performed for getting up this setup. So yeah, so because I'm traveling, so that is why I went for this pre-recorded sessions. In the end, me and both Xavier are present for any Q&A you have. So yeah, Mirko, can we start the session?
Sure.
Thank you. Okay, hi everyone. My name is Anish. I'm working in Intel and presently located in Germany. With me is Xavier. He's also working in Intel and located in Belgium. So today we are going to give one presentation regarding the overview of the MEC Hackathon setup for application developers. So basically this tutorial is providing an overview of the overall setup offered to the Hackathon participants, which all of you are the audience, with MEC servers available and remotely accessible for developers. And also the registered users will be able to try the openness and understand how to develop MEC application. So basically, I'll be telling the two setups which we for this for all the participants, or especially the developers who are participating in this hackathon competition and for MEC application. So basically, the agenda is divided into three parts. First of all, I'll be giving you the introduction about the MEC, one slide about the MEC overview. Then I'll be telling you what was the need for going for this special setup, for going for this special hackathon edge platform for the application developer, for which this whole presentation is about. And then what were the main consideration for going for this type of setup. Then on the second part, I'll be telling you about our partners who help us in providing this MEC setup, both on the hardware side and on the software side. So why we did consider, how we considered these partners, and what was our reason and consideration for selecting the software platform for the edge developers. In the third slide, I'll be going into the detail. First of all, of our virtual participation setup, which is something new which we did, and what this presentation is all about. And second, our face-to-face participation setup, the hackathon setup, which we offered to our developers and which we did previously. Then in the last, I'll be going for the conclusion, like what we learned after doing the setup and how it can benefit our other people, and how it benefit us and what are its advantages. So yeah. So first I'll start with edge computing, which all this hackathon is all about. That is MEC, multi-access edge computing. So as you know, in the COVID situation, and we have also felt, cloud computing has brought incredible transformation to all the businesses of all size, and very much visible during this COVID time, when we were able to do many of the things sitting at our home and online. But still, there are some use cases which are very much dependent on the latency and other things. And in future, with the 5G wide adaptation and enormous capabilities, there are some new relevant use cases which depend on the latency and the bandwidth is offered between the data generating device and the device which is processing this data. So previously, mostly it was done on the cloud compute, on the cloud side, but now with this new technology, it can be done at the edge. And this is what all about edge computing. So edge computing offers cloud computing capabilities within your RAN, within your radio access network, and provides an information IT environment at your edge. In other words, MEC provide new IT services that would be technically or economically feasible, but also really helpful in making maximum usage of the whole IT infrastructure. So as you can see in the diagram, so these MEC servers can be hosted at depending on your use case, depending on your latency expectation of the decision you want to take based on the data generated and what you want to do with this data. So it can be on premises edge, where you have a latency expectation between 1 to 5 milliseconds, or it can be on the network edge, that is on our mobile network providers, or you can process this data at our usual places, that is on the cloud. This edge computing spans a variety of network location, form factors, and functions. So cloud computing, as you see, what the main differentiator of this edge computing with respect to cloud computing is the proximity to the data generation device, ultra low latency, because you have to take some decision on this data, and maybe this, and later on this data generation device have to work on it. High bandwidth, as we see in the future, and now also with the advent of 5G, there are some use cases which need this high bandwidth. And the location awareness, especially in the field of autonomous driving, this location awareness is really helpful. So to promote this computing, Intel and its partner are usually organizing these type of events from last 2-3 years. They have happened previously in China, in UK, and this year it was in Italy. So yeah, as you were 25th and 26th, and all of you are participating. So why we do hackathon? What is the reason? So basically, the main goal of hackathon events are, first is the promotion. With every new technology, I think people should be knowing, the developers who can make optimum use of these technology and make some application which uses these standards and this new technology and make maximum usage and provide to the end user. And also, apart from this providing this information, I think feedback, whenever the developers or others engage in these type of event, make use of the mentioned software stacks or some standards, they really not only use the things, but also tells what are the shortcomings, how it can be improved, or provide the feedback. And the engagement, I think, if you don't have the first, the application who make application who uses these technology, and second are the edge platform developers, the service providers. They can be the people who are providing hardwares, and these all act as a new revenue generation for these people. So as rightly said by one of my colleagues, the publication of standard is not enough. It also need to reach out the end users. The community should be engaged to increase the adoption of that technology. In the past, we had some good technology on the standards, but because developers were not able to use them conveniently, they were not that successful. So we need these type of event to really tell what is latest in the mentioned standards or things. So yeah, we planned this, but as you know, this year the new problem came, the COVID-19 situation. So as we were working on to provide our developers, our participants, our audience, in January, February, March, we got this new situation. And then there was a need for the remote participation because of the lockdown and other unknown situation. We were getting feedback, and even we saw ourselves, it was very difficult for someone to come to the event venue and do the actual participation. So as like many other hackathons and other events, we went for we went for online or virtual participation. So apart from the audience who can see this event streaming on different medium, we also want our developers to participate in these events. And the only way was that we provide an environment which they expect when they are face to face in the place, like if you are directly located at the venue, and we need to provide the overall environment sitting to the participants or developer in their home. So this whole presentation is all about that, how we did that. what were our considerations, like what are our requirements so that we can replicate this setup, and what are the technicalities and how we collaborated with our partners and all. So I'll be going this step by step from here onwards. So what were the main consideration when we were designing this ecosystem? Like what environment we have to provide to the developers, and how this environment should behave, that it does not make any problem to the developer, if irrespective of it's on-site or they are participating online. So the first of all was the remote or cloud availability. That is like we should provide this environment to anyone sitting at their home or their workstation or their mobile device. If they have the environment, if they have the internet, they should be able to access this. So remote cloud availability of the engine environment was very important and important criteria for the successful execution and participation of developers worldwide. Second one was the isolation and privacy. Although we plan to provide this this environment remotely, but we should make sure that the privacy and the isolation should be maintained. It is not only intentional, but sometime by mistake also there is a problem. There is a possibility that developers or team enters into each other domain, maybe on the hardware side or on the software side. So we have to make sure that we do provide this isolation and privacy. So the provided machine setup must provide each developer team with its own isolated environment, with maybe if required dedicated OS and a edge platform which we provided using openness. Third criteria was providing this edge software development availability. So yeah, we do provide them remotely, we do provide them privacy, but we also need to see that what type of software they really need, this whole environment where they can develop some cutting edge applications which can make maximum usage of the standards which we are promoting, or this whole hackathon is all about. It's edge computing or MEC. So we thought about, and we saw that what type of environment we should be providing, what type of software stack or assets we should be providing to the developers, so they can take maximum usage of this environment and develop some cutting edge applications. And the fourth one is the repeatable and the fast deployment. So from March, what I remember, because of this corona situation, it was very unpredictable. Some places it was getting high, some places it was getting low. So we were getting feedback from our participants or our ecosystem partner that it was not stable. So we have to see some solution which is easily repeatable. Like if someone new joined, we should be very fast to provide them this environment, the whole edge where they can develop applications. So this was also one of the important requirements, that we should be able to do this repeatedly for the new participants or the team, and it should be fast. It should not take much time and effort. So yeah, to support a new team joining the hackathon, the server should be able to start new copies of the VM images. I'll be telling you later, like what type of individual software VM environment we have and how we were able to repeat this seamlessly and without any issues. So yeah, so we provided two type of environment. We went for the hybrid approach. So for the developers or the team who want to attend this remotely, we provided this virtual infrastructure, but there are some teams who were like some participants who was possible for them, so they can come and attend this face-to-face event also. So in the case of remote participation, there was no need to travel. All in case of issues, developer can take part to the competition fully online, from sitting from their home or next to their workstation. Wherever some participants who want to attend this venue, they can exploit, even like now they can exploit the presence of some great MEC experts or some speakers, and they can do this on venue. So for this, we collaborated with some our ecosystem partners. So with some of them we were working previously, like Cisco. So we were working them in the previous instances of this hackathon. And presently for this new virtual infrastructure, we collaborated with Equinix. So they are basically data center providers, and they have a very global reach. So they have like 200 data centers in 25 countries spread over the 5 continents. And we, for this virtual infrastructure, we need this type of a partner or who has a global reach, because our developers were coming or were participating from different parts of the world. And this type of availability was very important, especially for MEC related applications, which do a lot of dependency on the latencies. Yeah, so we collaborated with Equinix and Cisco. So on the software side, so as I told you, we were working that we provide a software development environment which allows the developer team at the hackathon to develop mobile applications for the advanced services in MEC-enabled 5G networks using ETSI MEC technologies and API. So we thought about an environment which is suitable for the edge application deployment. So we carefully selected some software stacks and other things which really will be helpful to the participating developers in developing these type of applications. So we selected basically OpenVINO, OpenNS, OpenAPI, and Location API stack. So yeah, and I'll not go into the details of all this. We do have some great sessions with some subject matter expert on this in our hackathon. But the main consideration was that to make maximum usage of the hardware and the software, taking care compliant to the ETSI MEC standards, and we went for these type of applications. So yeah, so first of all, we also use OpenS, that's Open Network Edge Service software, which promoted by Intel, but it's an open source software toolkit that enables highly optimized and performant edge platform to onboard and manage applications and network functions with a cloud-like agility across any type of networks. So it provides the same type of easiness when someone is deploying an application on the cloud to someone deploying the application on the MEC-based cloud or on the edge. So these openness related things are really good for offer unique capabilities to accelerate application development at the edge. They abstract out the network complexity for cloud and IoT developers, making migration of application to the edge very easier. They allow these type of here a developer can put their application both as a consumer consuming data from produced by some other application within the same framework within the openness, or maybe they also act as a producer. So it's a microservices based architecture which really allows developer to enable the application on openness as a standalone edge app, and it really is helpful. With me is Zaved. Do you have anything on openness? Any particular thing you want to add up on openness?
Maybe not now. Maybe as you mentioned, I mean, there is in the afternoon. I think it's at 2 o'clock on the 25th on the afternoon. There is another session on openness and all the details on openness. So I think we'll discuss that in more details over there.
Yeah. So as I mentioned previously, that will be a deep dive session on openness. If someone really want to see how the application can be developed or how is the openness platform. So now I'll go to the two main important things. The setup which we offer to our developers. First, what is new in this hackathon? That's a virtual participation for the developers who want to attend this hackathon competition virtually. So how they can, sitting at their home, they can access this edge environment with all the privacy and not particular any issues, and they feel like they are working on site. So I'll be going the step by step. What were the steps we did? Taking into consideration, as I mentioned in one of the previous slides, what were our consideration when we were thinking of designing this whole setup or solution. So virtual edge software development environment setup. So we need to provide one setup where this edge edge applications can be developed by the developers. So first of all, as I told you, or as in edge in MEC, latency is very important thing. So we, as I told, collaborated with the Equinix for different pod server selection. As Equinix has the worldwide reach, we selected some different pods at important locations in worldwide, which could act as our remote servers on which we can install our MEC supporting environment and all these things. So we collaborated with them, and we selected some of the collaboration, some of the servers. Most important of them were somewhere in US, Europe, in Amsterdam, in Shanghai, in China. So these can be remotely accessible by the developers sitting in the nearby location, and so taking care of the latency. So pod server selection, global server availability, and close to the developers, the important requirement. Second thing was the isolation and the privacy. So here we use our Intel VT technology, that's a virtualization technology, which was really helpful in us in creating some individual virtual machine, and which can be accessible outside, which can be easily accessible, but individual. So any developer or participating team can have their own application. They can test, they can put some simulator, or they can do the main, but in their own VM environment. So if there is any issue, or if they have some problem, it happens in their own VM space. So here we also use Intel, as I told, Intel virtualization technology. That's Intel VT. So third one is providing the environment and edge environment where we have all these different software application, which can be really helpful for any developers. So in the left, you can see one block diagram which tells how two teams, how we can provide a setup for two teams in one hardware machine, or one bare metal machine provided by our partner Equinix, using our new latest Intel Xeon processor. So in this, we installed also openness, and we installed our openness for providing this orchestrator environment for multiple application. So if you see in the screen, we have a bare metal machine. Above that, we have a host OS. Above that, we have a host virtual infrastructure manager. Here in our case, we took KVM, and above that, we installed 4 VM machines. And depending on what team have what type of application, we can provide, or we provided different type of software asset or software stacks. So in case of team 1, I'm just taking an example, they just needed 2 VM machines. One VM machine having the same compute node and the control node. And yeah, this is the first time also we tested the latest openness version, that's 20.06, which I'll be telling later on also, and we also used in our other face-to-face setup, that single node compute node and the both control node in a single machine. It can be a VM or it can be a native machine. And that feature also really help us in providing an environment which is very cost effective. So we don't need multiple machines previous to this release 20.06. We need individual machine for the compute node and individual machine for the control node. So this came as a blessing for us at the same time, and taking care of our cost effectiveness and the repetition. So if you see in the team 1, we have 2 VM machines. One VM machine having on the same VM, we have one openness compute node and openness control node. And if they want to generate some data for their application on this VM1, they can also have their data generator or some client simulation in the VM2. So we just need 2 VM machine per team. And similarly, if another team is there, we can provide the similar setup, but they have some more. Their applications are using some more software stacks, or like OpenVINO, which provide edge inference on the edge, or maybe one API taking maximum usage of the hardware resources on present. So we installed these type of stacks also on the same VM. So yeah, so this is the way we have like 2 teams using just 4 VM machine on a single hardware So really providing the different factors like isolation, repeatability, maximum usage of the hardware, and the overall edge software environment. So this is the overall environment, how a user who are sitting at home can access our machine, having the openness setup. So yeah, so anyone who have the access to internet were provided some static IP, which was provided by our partners, Equinix, and using that they can easily access our edge MEC environment provided for this hackathon. So these are the some points, like so client app running on a a developer can put their app maybe on a customer machine or on a client simulator, as I told previously. So they can have their data generation data app on the laptop or on the client simulator. So only one machine, only one server is required, which can serve up to the 3 teams. So this is what I mentioned previously. This was like an advantage in saving our hardware and the cost, and easy replicability. So one VM having the one controller and one edge node, and similarly one simulator serving per team. So based on the VM requirement, when we did this, we up to 10 VM can we support on these type of Xeon Intel-based Xeon processor, which were offered to us by Equinix. So again, this is the same block diagram which I have shared previously. So as it shows like what were the software assets we offered to the developers on the openness platform, MEC location API, one API framework, and applications like OpenVINO. And as I told this was the hardware space requirement. So it was like per team we just need 80 gigabytes of hardware space, and 48 gigabyte of RAM per team. So it was easy to host multiple teams within the same one setup. So as I told, this single node network edge cluster present in the openness 20.06 came as a blessing to us. So this was having a single node cluster scenario, that is a single machine working both as a control plane and a node. And it was developed for both the pod setups. And apart from like having the same saving on the resources of not providing individual machine for compute node and the control node, this is also helps in improving the reliability, because you don't have the point of failure. You have both the compute node and the control node on the same machines, maybe on the bare metal or on the VM. But that's a really useful thing when we are doing the final presentation. So this is what we offered, the whole setup, what we offered virtually to our different participants. So as I told what our hardware resources requirement, what our software assets we provided, and how they can access remotely these type of machines. So, but there were some other set of developers who wanted to attend this hackathon competition on site, that is from Turin, Italy. So for them also, we provided two type of configuration, and here our ecosystem partner Cisco helped us, which is one of the sponsor for this event. So if you see, we have shown two type of configuration. So the pod configuration one is the usual one where we need 3 machines for setting up 3 individual things: compute node, control node, and the client simulator. But with this latest openness feature of single node installation, we made some changes, and in the pod configuration 2 you can see that. So in the pod configuration 2 you can see that we have one machine, Cisco machine 1, with having both the compute node and the control node in the same machine. So there was a reduction in the usage of the hardware machine, and still we need a simulator which can be on the Cisco machine 2 or on the machine 2. So although, and there was not much performance degradation with the pod configuration 2. So if you really compare that, and in the pod configuration 1, the performance is best, but it takes a lot of hardware resources or individual machines for running all this.
Yeah, and maybe, Anish, something I'd like to add is, of course, if we compare to the virtual setup, I mean, the performance here is much, much better, right? This is one of the big difference. Here you have one team that accesses the whole computer. He has a lot of CPU cores available. This is the more typical edge deployment that the final customer will use, while the virtual, I would say, setup is probably not a very typical setup. So this is a much more typical setup.
Yeah, so this we used here, and even I think in the previous instances also we use something similar setup. So as I told, we use single node deployment using the latest openness platform. That this new latest feature which came with version 20.06, having both controller and compute node running on a single machine, help us in having the less hardware usage or less hardware resources usage. So saving on the cost side. So this is the final face-to-face setup which we had at Turin in Italy. So it shows an example of 2 teams, participant X representing team 1 and participant Y representing team 2. So in the team 1 or participant X, we have 3 individual machines, one for control node, one for edge node, and one is client simulator. Whereas in the team 2 or participant Y, we have a single node installation having both controller and edge node in one machine and the client simulator on the second machine. And these can be individually accessed by the developer or the participant located at the venue using their IP and port. And here the Cisco really like to thank for helping us in providing this whole setup. Javed, do you want to add something on this? So Javed mostly worked on this setup. So yeah.
No, I think you explained it. So thanks.
Yeah. Okay. So yeah, as I told previously, it was a single node deployment and really helping us in reducing the cost. So Cisco provided us some cluster of 6 UCS server-based machine, which was having Intel Xeon processor, giving the maximum performance.
Yeah, maybe one thing to add here is that on those setups, we're also able then to add additional cards like VCSA cards or FPGA cards with DDL, whatever. I mean, are needed for this hackathon, which is much easier than in a virtual in the virtual event. So this was possible in this setup if needed.
Okay. Yeah. So yeah, there are some advantages when you have face-to-face setup. You cannot provide everything virtually. Yeah. So I'll just end with the conclusion of what were the advantages of using this cloud-ready network outside solution. So basically, apart from providing this environment to the virtual participation, it was also was helpful for really finding the edge deployment related issue. This is very new technology or new area I think these type of events not only help us in getting the feedback, but really help us also to know what are the problems we can face in during these deployments. So yeah, we did that. So apart from that, virtualized solution leverages virtualization technology to install openness so that edge computing infrastructure can be shared, replicated, and installed quickly. So it proves that, yeah, with this type of virtualized solution, we can easily replicate these type of setups in reuse in future for similar events, maybe where there are large number of software developers in a very affordable way. So it's repeatable and scalable. For yeah, apart from that, yeah, MEC promotion and adoption, robust and flexible edge computing solution based on the open source reference implementation can accelerate innovation within the industries. And having all these type of hackathon event really help us in propagating these type of technology within the developers and within the edge service providers. So yeah, so these are the main what conclude what we have, and this is how we can use this in future. So basically, this whole work has also been documented what we did and all that in a white paper, which is being hosted in our company website. And this is a link, and later on you can go and see various steps we found, how it is useful and what were the consideration. And I think that can be a good information for anyone who want to replicate these type of setup for their environment or similar usage in future. Hi. So I think this was the first video, and now I'll be showing you one more demo video. Basically, it tells what were the actual steps we did to get this whole hackathon set up. So I took some screenshot of the various steps we executed, starting from having account creation provided by our partner Equinix, then the VM creation. So maybe Nico, can we play the second?
Hi everyone, I hope in this COVID situation all of you are safe and doing great. This demo video will present solution for MEC systems that is designed for virtual participation in the hackathons. You will see different steps executed for the creation of this environment. Intel collaborated with Equinix for the virtual participation infrastructure creation. Equinix is a leader in global colocation data center market share, with 210 data centers in 25 countries on 5 continents. For the hackathon virtual participation, we selected Intel-based machines in different geolocations as we can see in the figure. Equinix global presence, taking into consideration that pod location should be as close as possible to participating team geolocation. As we all know for MEC, ultra-low latency, that is in milliseconds, is a critical KPI for real-time applications. The remote version of the hackathon hardware environment was based on the Equinix Metal product, the N2. Extra large configuration was used. Equinix Metal is a bare metal as a service offering that is available in multiple locations globally. Figure, you can also see the hardware configuration of Intel-based machines used in a MEC pod. The example we are showing is of the pod located or selected in Amsterdam location for virtual participation of a team from Europe. Step 2. VMs creation. Virtualization infrastructure main components which include libvirt, virt manager, QEMU-KVM, is installed on the bare metal server machines. VMs are created as shown in the figure following the configuration described in the openness website for the hardware requirement for the respective openness installation kit. You can see here VMs created both in the command line as well as the virt manager graphic user interface screens. All this is supported by the Intel-based machines having Intel's latest virtualization technology. Step 3. Pod external access. While the cloud provider, Equinix, provides only a single static IP to the bare metal host system, Port forwarding enables each participating team with direct access to the target VMs assigned to them, therefore allowing access to the target machines from the ease of the home that is anywhere and anytime access. For example, table shows mapping of internal IP address to external IP address mapping for 2 VMs. Step 4. Edge Application Development Environment. Openness installation. We opted for the latest openness platform, release 20.06, having both controller node and compute node running on a single VM. The example in figure shows a deployment used by 2 developer teams. Team number 1 has 2 VMs assigned, VM1 has both controller and compute node, and VM2 has a client simulator. Team number 2 also has 2 VMs assigned VM3 and VM4 where the VM3 includes not only openness, but also one API and OpenVINO toolkit installations. Final configuration of the end-to-end environment provided isolated environments for each of the participating teams, each with its own OS on a single and powerful platform. Figure shows the final configuration of the end-to-end virtual hackathon environment for application software developers. In the provided setup there was a client app running either on customer laptops or on the client simulator, for example, for debugging testing purposes. Customer laptops connected to the edge node through the internet. The client simulator that could be used to test openness setup locally without the data plane going through the internet or in the case of internet issues, connectivity, low throughput, high latency.
So this is all from my side. I think if you have any Q&A questions. Dario, we cannot hear you.
Thank you so much, Anish, for the presentation. Thanks.
Okay, thank you.
Okay. So I don't know if there are any questions. Yeah. If there are no any other further questions, I think now it's time to move to the lunch break. We can still be here for any questions until 12:30 European Central Time, and then there is the lunch break until 2 p.m. Okay. Thank you. Okay, so welcome back after the lunch break, and we are here for the MEC Hackathon, the afternoon session for the day 1. So according to the agenda, we have for this afternoon 3 tutorials. So the first one will be a deep dive on openness, and then hands-on session with one API, and then developers, startup, and edge innovators ecosystem in the 5G era. So let me introduce my colleagues, Aniket and Xavier, who will give this tutorial and deep dive on openness after the introductory section this morning. Now we go more in detail, technical detail about the MEC platforms and the other toolkits offered in the environment. So thank you. And Aniket, the floor is yours.
Yeah.
Thank you, Dario, for the introduction. So I'll start sharing screen. I hope my screen is visible.
Sure.
Okay, thank you. Okay, so very warm greetings to everyone present here. I hope that everyone is doing well in these trying times, and I also hope that everyone is recharged after the break. So, as Dario introduced us, my name is Aniket Dev, and I am a senior software engineer at Wipro, and I will be presenting alongside Xavier, who is a senior software engineer at Intel. Today, we are going to talk to you about openness, what it is, what it does, and what it can do for you. Just one reiteration, please post any questions that you have in the Q&A chat, and we will gladly take them up at the end of the presentation. To quickly take you over today's agenda, we first have an introduction to openness. Then we'll see the different scenarios in which openness can be deployed. Next up, I'll take you through the architecture of openness and the features that openness has. Finally, I will briefly explain what openness can provide to the application developers. So let's jump right into it. So the concept of edge computing was beautifully explained in the morning by Mikkel. So I will just briefly summarize it so that we can understand openness with some continuity. Edge computing is basically providing execution resources, both compute and storage, for applications with networking requirements close to the end users. The main objective is to reduce latency and provide high bandwidth. It also aims at providing device processing capabilities at the edge and also data offload to applications. Openness stands for Open Network Edge Services Software, and it is Intel's Edge Reference Architecture, which is compliant with 3GPP 5G as well as ETSI MEC standards. Openness enables highly optimized and secure edge platforms to onboard and manage applications with cloud-like agility. So we basically have two distributions of openness here. The first one being the open source one, which is a completely cloud-native microservices-based edge solution. It has a public Apache license, and it is completely open to community contribution. You can find all the code and modules and files on GitHub. The second one is the Intel distribution of openness. It is basically an enhanced version of the open source one, which is optimized to deliver best performance with Intel hardware and software. So to put it simply, it has some extra features. Openness, as I previously said, is a completely cloud-native microservices-based edge solution. To give a brief description of microservices, it is an architecture in which an application is a collection of highly maintainable, independently deployable services. Now, whenever we talk about microservices and cloud-native, the first thing that comes to our minds is containers. And really, what better way to orchestrate containers than Kubernetes? Openness is built on top of Kubernetes, which is a production-grade container orchestration environment. One thing that I did not mention previously is that openness is completely access network agnostic. What it means is that you can run it across 4G, 5G, as well as wireless network as long as there is a reachability. Openness can also be described as being modular, which means that parts of openness can be consumed independently. Let us look at some of the top use cases of openness. They include AI, computer vision inferencing apps at the edge, media applications, analytics applications, applications requiring SD-WAN, amongst many others. In the center, we can see the building blocks of openness. I will go into further detail of each block in the following slides. So for now, I would like to highlight a feature of openness, which is worth mentioning, that it is optimized for edge KPIs. KPIs is key performance indicators such as throughput, QoS, quality of service, latency, jitter, etc. So let us take a closer look at the building blocks of openness. Starting with multi-access networking, it includes 3GPP network function microservices, which enable deployment of cloud in a 5G network. Openness provides complete support to operators and 5G vendors to create and integrate network solutions. Next up, Edge multi-cluster orchestration manages vast number of applications distributed in Kubernetes clusters very effectively. Service mesh is a way to control how different parts of an application share data with one another and communicate with each other. It allows low latency communication between application processes using APIs. Openness utilizes edge-aware service mesh for a better performance. Moving on. Network overlays are a method of using software virtualization to create additional layer of network abstraction. This provides better optimization and security. SD-WAN is one such overlay which has been made edge-aware by openness. Openness also provides additional security for data and intellectual property, even in a system where multiple clients exist on the same software instance. The last three that I mentioned, which are marked with an asterisk, they are in the pipeline, and we will see them more prominently in future releases of openness. So resource management is effectively done in openness using Kubernetes plugins such as Topology Manager, Node Feature Discovery, Resource Management Daemon, Core Pinning, etc., which we will explore in the upcoming slides. Data plane CNIs, or container networking interfaces, is an interface between a container runtime such as Docker and network plugins which enable the container to connect to a network. Openness utilizes the optimized data planes for various use cases. Openness also utilizes various device plugins available with Kubernetes for acceleration cards such as visual processing, graphic processing, and field programmable gate arrays. A very important building block of openness is telemetry and monitoring, which uses industry-grade frameworks such as Prometheus and Grafana to provide application and platform-level telemetry. Lastly, contributing to a sustainable and green future, openness helps in scheduling services while avoiding power consumption at hotspots and at times of emergencies. I would like to say that these building blocks are not really components of openness. Rather, they can be thought of as principles and guidelines that openness follows. So let us look at the different scenarios in which openness can be deployed. Now that we have explored the various building blocks on which openness functions. So here we have classified the entire diagram on the basis of the latencies, and the edge, as we can see, has been divided into two parts: on-premise edge and the network edge. On-premise edge is closest to the end user. Let's take an example. If the end user is an IoT device, such as a speed sensor on a road. The on-premise edge may as well be a traffic light nearby on which the application can be hosted on, say, any small form factor server such as an Intel NUC, which can be housed in the power box of the traffic light. And that's an example. Like, it might be risky in the power box, but anyway. Or it can also be a hospital server room where a heart rate monitoring application is deployed, and it receives data from the heart rate sensors in each room's patients of the hospital. So from the examples, we can understand that the ultra-critical latency-based applications can make the best use of the on-premise edge, since the latency of the on-premise edge is usually less than 5 milliseconds. Network edge is usually the aggregation site or the near edge, the cell site, the access edge, or a regional data center, which is managed by the same communication service provider as the end user. The latency here usually ranges from 10 to 40 milliseconds, which is for the less critical applications and the applications that can be deployed in this category. What I can say is that they are the applications that need to be scaled, since scaling at the network edge is done more easily. The architecture of openness basically shows that it has two major components, as we can see. On the left side, we have the openness edge node, and on the right side, we have the openness Kubernetes control plane. So remember when I said that building blocks were not the components? These two are the components of openness. So let us start with the Kubernetes control plane. So this consists of microservices, Kubernetes extensions, and optimizations that help with edge node configurations. Also, life cycles of the deployed applications on the edge nodes are managed by the control plane node. Kubernetes dashboard is used as the user interface to monitor the applications and resources managed by the control plane node. On the other hand, the edge node, which also consists of microservices, Kubernetes extensions, and optimizations, they are needed by the edge applications and the network functions deployed on them. It consists of APIs that are often used for the discovery of application services. The edge node also has a system pods consisting of services that enable reporting of the hardware and software features to the control plane. It is important that I mention that there is also support for a real-time kernel for low latency applications and network functions. One thing that you might notice from the diagram is that we have specifically mentioned hardware, the CPU, memory, NIC, acceleration cards, GPAs, FPGAs, but we have not mentioned anything as such for the Kubernetes control plane now. This is because as long as there is connectivity, we can house the Kubernetes control plane on a cloud as well. However, it is generally preferred that the edge node is a bare metal server so that we can completely utilize all the hardware capabilities that it can provide. Currently, the OS supported by openness is CentOS. As we have seen so far, openness is an open source platform that enables easy orchestration of edge services across diverse platforms and technologies. Certain commercial crowd service providers such as Amazon, AWS, Amazon Web Services, have a provision for running a cloud app on edge platforms external to their own cloud. In the case of Amazon, this is provided by the Greengrass product. In Greengrass, a cloud connector component called the Greengrass core is ported to the Edge platform, and it interoperates with the AWS cloud to allow the cloud to deploy and provision cloud applications on the Edge platform. This component runs on the Edge node as a Docker container, and it provides network interface to the AWS cloud. Like other applications, Greengrass also uses node services to provision cloud applications on the Edge node. Hence, openness adapts outstandingly well with external cloud technologies and seamlessly deploys their apps as well. So basically, if you have an app on the cloud, it's just a few clicks and your app is deployed on the Edge. Now that we know about the basic components of openness, let us explore the CNI supported by it. Openness supports multiple container networking interfaces. However, the default CNI for openness is kubeOVN. kubeOVN demonstrates the capabilities of a standard data plane, such as OVS, for an edge compute platform. It is a very robust CNI, which also provides security from the underlay network through encapsulation. The second most popular CNI supported by openness is Calico. Calico ensures a higher performance. However, since Calico doesn't use encapsulation, the application pods might get exposed to the underlay network during deployment. Next up, SRIOV leverages the idea of physical and virtual functions. Here, a physical function is used by the host, and each virtual function can be treated as a separate physical NIC and also be assigned to a container. WeaveNet ensures faster cluster uptime than its competitors that I mentioned above by enabling something called the automatic container discovery. Multa CNI, on the other hand, enables attaching multiple CNIs to pods in Kubernetes. To give an example, you can attach both kubeOVN and SRIOV if you have Multa CNI enabled. And that is not all. Openness also supports other CNIs such as Bond CNI and User Space CNI. The main objective is to provide different kinds of application developers the freedom to work with the CNI which suits their purpose. It is important that I introduce EPA before we deep dive into the features of openness. To put it simply, Enhanced Platform Awareness, or EPA, is, as it sounds, to become more aware of the underlying computer architecture and hardware, so that optimizations can be done to enhance performance. Following are the EPA features which are supported by openness. I will take you through some of them and explain what they do in more detail. However, let's go through all of them once. BIOS or firmware configuration, topology manager, huge page support, node feature discovery, SRIOV, CPU pinning, OVS DPDK, RMD, which is resource management daemon, telemetry, and FPGA or HDDL support. So let us start with the one I briefly touched while we were exploring CNIs. OVS, or Open Virtual Switch, is a robust data plane CNI which helps to accelerate data throughput with the use of DPDK. DPDK stands for Data Plane Development Kit, and it is a set of libraries which help in accelerating data packet processing and increases the throughput of data through a NIC interface. DPDK does so very efficiently with the use of huge pages and translation look-aside buffers. Coming back to OVS, OVS helps in configuring network interfaces and adding them directly to containers via tools such as OVS Docker. It can also configure data plane routing as defined by an SDN controller, that is OpenFlow, using the command ofctl. OSCTL also has provisions for prioritizing certain connections over others by giving them priorities. Since the DPDK replaces the IP stack, if we did not use OVS DPDK, we would have to use a more traditional approach around the kernel stack packet routing, which might have significant performance implications. Next up, node feature discovery. So as the name suggests, it helps us find out features of the node hardware and broadcasts it to the orchestrator. This enables better placement of workload for optimized application performance, and it enhances manageability. Without NFD, application deployment on the wrong node might hinder the performance. And let us take an example here. Looking at the figure here, let us take an example of a CDN service. So let's say the CDN service has two components. One is the CDN application, which does suppose video processing, codec conversion, translatings, transcoding, and other functions. While the other component is an Nginx application, which acts as a web host and a reverse proxy. So let us have, say, two nodes. The node 1 being a plain old mundane server, which at times might even run slower than a flagship phone. And on the other hand, we have a completely buffed up and a high-spec server with features such as Turbo Boost, SRIOV, Secure Boot, AVX, etc. So wouldn't it really be tragic if by some reason the CDN application gets deployed on node 1 and the Nginx application gets deployed on node 2? Wouldn't it be better if we knew beforehand about the server specs so that we could deploy the main CDN application on node 2 and the Nginx application on node 1? So this is basically what node feature discovery does. I will also explain this in the further slides when FPGA comes up as to how node feature discovery helps with that. Okay, so to explain Topology Manager, I will first give a brief overview of NUMA. NUMA stands for Non-Uniform Memory Access. It means that a processor can access its own memory faster than a non-local memory. Why is this relevant? In the beginning of the IT industry, the CPUs were generally not faster than the memories they used. However, that is not the case today. For most use cases today, the CPU usually dies of boredom while waiting for the data packets to reach to it. Thus, using huge pages from its own socket memory can boost the performance of a core by multiple times in use cases which require high data throughput. The Topology Manager basically exposes which socket is attached to the network card and facilitates better orchestration of applications. As we can see in the figure here, at the top, the system is not NUMA aware. There are two sockets, and even though the NIC is attached to socket 1, the application is deployed on the CPUs of socket 2. So it has to route the packets through the bus that connects the socket 1 and socket 2. However, in the bottom node, which is NUMA aware, the Topology Manager helps us deploy the app on the cores of CPUs attached to socket 1. This way, the network card is on the same socket as the memory which is used by the cores, and this can help us achieve better performance and also improve the manageability of the application. Last but not the least, telemetry-aware scheduler collects and exposes platform telemetry to control plane, which can also monitor the performance of nodes and mitigate the workload accordingly. TS, as I had previously mentioned, uses industry-grade software like Prometheus and Grafana to achieve this task. Prometheus collects metrics from the monitored targets, and Grafana acts as the visualization layer. Let us take an example of how this could be useful. So let there be two locations, location A and location B, with content delivery networks, which under normal circumstances can hold their ground in terms of the streaming load. Now say that node A is the Camp Nou Stadium in Barcelona, and it is streaming the FIFA finals. Now there is no doubt that the Camp Nou Stadium node will be overburdened by the streaming request at this point of time. So the TS will notice that there is a serious bottleneck at node A, and the Kubernetes will identify that a nearby node B is capable of additional load. So what the service provider can do is that he quickly deploys the streaming app to node B as well, thus sharing the workload and providing an uninterrupted service and good quality of service to the end user. Now all the features and CNIs and building blocks and everything that I've covered in the previous slides, the most important takeaway is that you, as an application developer, don't have to worry about it at all. It is like you tune the hyperparameters of an ML model. You just have to choose the features and openness takes care of the rest. So let's actually get started with the implementation of openness. Intel strongly believes in the philosophy of testing out the stuff before buying it. So all the necessary softwares and modules required for application development are available on GitHub. These can be consumed individually or as a whole. Intel not only supports application developers, but also infrastructure developers and system integrators. In other words, infrastructure developers can utilize the cloud-native edge platform with core building blocks, and application developers can create apps with the available solutions and see the difference in the performance with and without the product. One thing that we can see on the left side here, which is new, is SERA. SERA, or Converged Edge Reference Architecture, is a method to leverage 5G to bring about smart devices and IoT on the edge. We will go into further depth on SERA in the upcoming slides. So here we can see how openness accelerates the complete process of service innovation at the edge. Not only that, it also reduces the total cost of ownership to an organization in the process. It is like you have already placed an order for your food, and as soon as you reach the restaurant, the food is ready for takeaway. Wouldn't that be cool? There is no wait time. So continuing with this analogy, rather than creating a service from the scratch, developers can utilize the existing openness building blocks, and integrators can reuse the pre-assembled SERA. For a network engineer, what this means is that he does not have to manually configure and recalibrate the network from a scratch. There is a predefined multi-access edge networking available for high performance already. Finally, the IT engineer can deploy and monitor the service with ease, thus not only reducing time, but also the efforts of the concerned parties. So all in all, we are helping you cut short the nitty-gritty of networking and orchestration and only focus on application development, and then provide you with easy deployment solutions. Now that we are coming to the actual implementation of openness, let us understand what openness experience kits is. Openness uses Ansible playbooks to automate the entire installation process from the get-go. There is a provision to install individual modules via Helm chart as well. This is what I meant by the statement that openness is modular. However, if you install via Ansible, There are certain predefined flavors which set the system for a certain kind of workload. As we can see here, the flavors are minimal, FlexRAN, CDN caching, service mesh, Sera, and media analytics. While explaining the NFT example, we had briefly grazed to the CDN caching flavor. And by the end of the presentation, we would have gone through, at least over the top, over all the flavors of openness. So let us dive deep into some of them. Before I explain the FPGA acceleration card, let me briefly explain what RAN or radio access network is. It is basically the edge of the wireless network. 4G and 5G base stations form the key network function for the edge deployment. In openness, FlexRAN is used as a reference for these 4G and 5G base stations. So what is FlexRAN now? Technically, FlexRAN offers high-density baseband pooling that could run on a distributed telco cloud to provide a smart indoor coverage solution and next-gen fronthaul architecture. There were a lot of technical terms in that definition. So let us break that down and understand that one by one. So baseband pooling is required at times when network bandwidth is limited by processing resources. Next up, a telco cloud is the data center resources required to deploy and manage mobile phone networks. And fronthaul is the network that connects macro cells to small cells in the mobile network. So to sum it up, what FlexRAN does is that it makes these resources readily available at the edge. So the FPGA PAC N3000 is a programmable acceleration card which the FlexRAN flavor utilizes for functions such as forward error correction. And forward error correction is a method of obtaining error control data in data transmission in which the source sends redundant data and the destination only recognizes the portion of the data that contains no apparent errors. That's just one application that FPGA does. It has many more. FPGA has several Kubernetes plugins which help in automating the remote programming and resource allocation for the FPGA card. Remember when I said that while explaining FPGA, we will encounter NFD once more. So NFD helps in checking if a server has an underlying FPGA card or not. It helps us with the version of the card, the firmware installed, the status, etc. And FPGA RSU is a microservice that the Kubernetes plugin provides, and it helps us with upgrading the firmware, rebooting the service hardware, etc. By now, we have come across service mesh quite a few number of times. So service mesh is a way to control how different parts of an application share data with one another and communicate with one another. Openness achieves this with a service mesh based on ISTIO. ISTIO ensures intelligent control of traffic flow and API calls between services. It secures the connections via authentications, authorizations, and encryptions. ISTIO also generates detailed telemetry for all service communications within a mesh. This telemetry provides observability of service behavior and better management capabilities. As we can see in the figure, the 4 pods on the edge node of media analytics application communicate with each other via the ISTIO gateway. Each pod of the application, which we can see in the blue, has an ISTIO proxy service running within. Moving on. So, Sera. It's a cool name, isn't it? Anyway, so what is Sera and what does it do? Today, service providers are struggling to keep up with the demand from enterprise edge customers who want private wireless networks for their connected smart devices. Building, testing, and onboarding new solutions at the on-premise and outdoor edge is both costly and complex. This can be attributed to multiple burdensome regulations, funding constraints, and lengthy development times, thus all of them impacting the development. At the same time, many customers are also seeking an effective solution to evolve their private networks beyond Wi-Fi and Ethernet to include 4G and 5G wireless. However, this needs no mention that this requires additional investment in wireless. So some statistics now. The projected number of IoT devices by 2025 is about 22 billion. That's a huge number. So this is where Sera comes in. Sera unifies and converges the IoT with wireless infrastructure network technology to simplify workload convergence at the edge by leveraging 5G for smart devices at the edge. It does so by providing a single platform for sorting out multiple workloads such as AI, networking, media, etc. Sera effectively utilizes the complete potential of Intel hardware along with other Intel-provided softwares such as OpenVINO, openness, FlexRAN, etc. This helps the customer realize edge value, expand services, and scale their edge IoT solutions confidently and seamlessly from the cloud to the edge. Coming to the part that is more relevant for the developers, how do you go about developing an application that can be readily deployed on Openness Edge platform? So I'll be taking you through a video analytics example which uses the Intel OpenVINO toolkit. Let me briefly explain what OpenVINO is. OpenVINO is basically a set of libraries that help in extending computer vision and non-vision workloads across Intel hardware, thus maximizing the performance. It accelerates applications with high performance, AI, and deep learning inference that is deployed from the edge to the cloud. It basically makes it easier for CNN-based deep learning modules to run on low form factor servers. So the main part an application developer has to take care of is the authentication between openness microservices and the application. As we can see in the example below, an application has been divided into the producer and consumer, and the communication mostly happens, which is shown in the blue and the green dotted lines, between the producer, the consumer, and the EAA. EAA standing for Edge Authentication Agent. So let us use an interface diagram to explain it better. So in the diagram, as we can see, on the right side we have the Openness Edge platform, and the Openness application is basically divided in three parts: the producer app, the consumer app, and the OpenVINO C++ libraries. So the first thing that happens post deployment is that a certificate handshake happens between the EAA and the producer. Once the certificate is verified, the same is sent back to the consumer and a WebSocket is connected. The consumer then requests for the services provided by the Edge platform, and certain services are subscribed to. For the sake of this example, let us take vehicle detection as the model that we have subscribed to. Now that authentication is done and the services are selected, the producer constantly broadcasts the model that needs to be used by the consumer and for the end user to avail the service. The consumer gets this information of the model that needs to be used through the WebSocket, and voila, the vehicle detection is done. It's that easy. So that's all for the presentation that we had. To get in touch with us, you can access the following sites, and you can also mail us at developer@mail.openness.org. Thank you.
Thank you, Aniket. I think this is a great presentation. Thanks so much. I think now, yeah, we have still some minutes to discuss openness before next speaker will arrive at 3 o'clock. So we have a kind of a quarter. Let me open the floor for questions.
Yeah, sure. I'll move on to the chat window. I'll look at the questions.
So first question from my side, just as an icebreaker. Huh? Okay.
Yeah.
So in your experience, this is let's say a toolkit that is used mostly by developers in edge computing. So in which kind of use cases are you seeing recently that mostly benefiting from this platform, this toolkit? Do you have any recent experiences on that? Which is the use case that you can mention can be as a useful and nice example for application in openness?
Yeah, definitely. So we have been seeing use cases regarding video analytics a lot, specifically speaking in traffic scenarios. We have also seen use cases for video conferencing solutions that need to be deployed using the network edge. Those were some of the use cases, to name a few. We have also seen use cases such as target value, high value target protections, to name a few.
Okay, yeah, thank you very much. Let me wait for questions. Okay, yeah.
Anish Rawat is asking where can we get
So there was a question to everybody a couple of minutes ago where we can get the slides presented in this session. Sorry? Okay, Aniket, maybe your connection is not good. But yeah, of course. So the plan, guys, is to present to publish the slides, all the presentations as a proceeding for the event, and also the plan is to publish a link for this recorded set of video streamings, so that people can also watch the entire event even afterwards. So, any other questions? Let me tell you that we are still here, but the next talk is planned for 3 p.m. European time. So I propose, in case there are no questions, let's take a break. I will just simply switch off my video, but we will be there in any case, all available. And please, Aniket, stay connected still for 10 minutes, because next speaker will talk about one API, but still they are based in US, and still this is very early in the morning, so we have to start in time, not earlier than planned. So let's wait for the next speaker. In the meantime, let me also encourage people to put questions also in the chat window, if any. Otherwise, in any case, we are here. Okay. Let's reconvene at 3 o'clock. Thank you, Aniket. Thank you, Xavier.
I have one question, Aniket.
Oh, please.
Yeah. So you were telling about this openness installation on the bare metal and on the VM. So my first question is, how much is the performance difference between the two? Like, did you find some problem in one of them compared to other? And second, did you have like actual someone running the openness in a VM?
Yes, sir. The main difference that I can tell you is that we'll face certain differences while translating the network cards from the bare metal to the VM. We'll basically have to create virtual functions for them while switching on SRIOV, which is much more easier in bare metal, where we can directly port them to the applications as needed. That is one of the major differences that is observed between VMs and the bare metal.
So it's on the implementation side or on the performance side?
This one is for the implementation side. On the performance side, as long as we are assigning the cores on the same socket for the applications as the network interface card, we won't see that much of a difference in the VM as compared to the bare metal.
I think maybe something that we might have if we start using VMs is that I would say in the same way as we use Kubernetes, NUMA, EPA, right, when we go on bare metal, if we start using VMs, those VMs must be deployed in a proper way as well, right? And then this is out of the context of openness. How do you deploy those VMs so that they are also NUMA array and so on, so that they also use the EPA features? So this might add some complexity. So yes, typically we could probably have the similar kind of performance, I mean, depending on the number of cores and so on, but it becomes really dependent on the way you install your VMs. So I think it's one of the big differences.
Okay, so you're saying VM should also be properly optimized to get the maximum usage. Okay, thank you. And second, do you have any like actual situation where you use this VM? Any use case or any customer who are using this openness on a VM? Just curious.
Like for internal testing, we have tested like FlexRAN, the flavor FlexRAN on a VM, and it worked well actually.
And I would say something similar. I would say most of the usage I've seen from a VM perspective are probably like in lab and stuff like that. I haven't seen much, but of course, I mean, I don't have a complete view. I haven't seen real deployments probably on VMs, but quite a few people using this in labs or for us, I guess, right in the hackathon, for instance.
Okay, thanks.
Thank you. Okay. So let me switch off the video from myself, but we are still here, open for questions and discussions. And next speaker will be at 3 o'clock. Okay, thanks. Yeah, so thanks again for reconnecting. We are back again with the afternoon sessions. let me welcome for this tutorial Benjamin and Adonai, who will give a hands-on session with one API. So yeah, thank you, and now the floor is yours. You can talk and present your slides. Thank you so much.
Okay. It doesn't allow me to share my slides yet, Dario. It's all great. Oh, okay, there we go. Is it look correct now?
Yes, perfect. Go.
Okay, fantastic. Well, good afternoon, everyone. My name is Ben Odom, and I'll be joined by Adonai here. I'm from Intel. Been here on the west coast of the United States, so it's a little early in the morning. So if I make mistakes, please forgive me. It's not even daylight here yet. But I wanted to thank you for the opportunity to talk about Intel and OneAPI. So we're going to talk about quickly just an overview to OneAPI, give you guys a chance to understand what the Intel DevCloud is and how you can use it for your projects, give you a brief introduction to Jupyter Notebooks, which will be key to the hands-on component that Adonai is going to take you through, give you a brief overview of Data Parallel C++, and talk about some of the new features that it introduces, like universal shared memory. And then we're going to go from there. Instead of a complex number multiplication example, we're actually going to use an FPGA Hue transform that Adonai is going to walk you through. So I can't see the chat in this mode, so if you guys have questions, I'll pause every now and again, and you guys can ask.
I can help you out as well.
Oh yeah, if you guys just want to put them in chat, Adonai can knock them down too. So you know, as you guys think of them, go ahead and do that. So why do we care about heterogeneous computing? The term refers to systems that use, you know, multiple kinds of processors or cores, and not just your traditional CPU cores. It could be an FPGA, an ASIC, you know, some custom piece of hardware, you know, GPU, you name it. And the idea is to take advantage of everything that's available to you in the system, rather than having a bunch of silicon just sitting there doing nothing. And hopefully this gives you, you know, better performance, more efficient power per compute, improve your latency, you know, hopefully check off some of these items highlighted here to improve your application and to improve, you know, the performance of the system itself, you know, making it more efficient. But there's a challenge. Programming for multiple architectures has never been straightforward. Typically, each kind of hardware needs to be programmed using a different language, probably a different set of libraries, tools, code bases, which require a developer to, you know, effectively write their application 3 times. And it's tough to keep up, right? I mean, languages are constantly evolving, tools are coming and going, and what we're trying to help is eliminate the need for developers to learn so many different types of tools, libraries, et cetera, and just be able to focus on a heterogeneous compute model that hopefully has long-term stability and ability to apply to a diverse set of hardware out there. So to that end, our solution is what we call OneAPI, and it's a project to deliver a unified software development environment across CPUs and whatever accelerator architecture might show up in the future. This is an industry initiative based on open standards and open specifications. It includes a unified language and libraries that, with the goal of delivering full native code performance. Full transparency, the main effort today has been definitely working on this cross portability with performance really coming on as let's see, we're in beta 10 now with the gold release coming here in early December. Where, with the targets that we've chosen so far, you are seeing very good performance across all of the targets. One API is also a foundational programming stack, and you'll see that it's not only a open industry standard, but it's also used to optimize middleware and frameworks that sit on top of it. Two of our most popular are TensorFlow and PyTorch. You might also see it inside of Intel's distribution of Python and like Numba and SciPy, where they've used one API components to accelerate, math functions and things like that. So this industry initiative is an alternative to a single vendor solution. Our goal is to build something that simplifies development across multiple platform types and processors and accelerators, not just Intel's hardware. And that's kind of key here, right? So this is not just only going to work on stuff built by Intel. It's going to work on stuff built by AMD, NVIDIA, name your hardware vendor. Everyone's welcome to come and put forth a solution that takes advantage of one API. The one API specification includes a direct programming with an open programming language called Data Parallel C++. That's the hands-on example that you'll see today. One API-based programming is a performance library for expressing parallelism and delivering native high-level performance for all supported platforms. And Data Parallel C++ is the basis for a lot of the trainings we use to showcase one API. And we'll show you I'll show you the dev cloud later today. And there's a ton of training up there that you guys can explore Data Parallel C++ and take a look at a bunch of programming examples in a hands-on environment. So the goal here is to promote an open standard, utilize the community, and hopefully, support code reuse across multiple architectures and vendors. So just talk about a little bit more about Data Parallel C++. This is really a high-level language. If you're familiar with C++, you're probably very familiar. It will take you no time at all to spin up on Data Parallel C++. It provides the full native high language level compatibility. It simplifies code migration from proprietary languages and programming models familiar to GPU and software developers. It uses SYCL 1.2. As a matter of fact, many of the Data Parallel C++ programming features are in the SYCL 2020 spec from the Kronos group. And what we're trying to do is address the programming gaps, the language gaps, through extensions that will drive into the standards. One of the examples being USM, Unified Shared Memory. All of this is open source. You can see all of it on GitHub if you look up Intel Data Parallel C++, the base kit, the HPC kit. It's all up there on GitHub, and they accept pull requests. You can take a look at it. It uses our compiler, plus we also use the LLVM compiler, which helps us get to the offload devices. Now, it's not a one-stop solution. Full transparency here. You will need to tune for each architecture. There are, every platform has a little bit, but we have tools that can help you with the Intel Advisor, Intel vTune. I think you might have had some talks on those earlier today, or maybe happening later tomorrow. So the difference between SYCL and Data Parallel C++ is there's so much parallelism available. We needed a more abstract model to allow you to reason about how to go about programming across multiple architectures and multiple devices. We're really trying to enable specialized hardware accelerators that will require, take your performance beyond the CPU, take advantage of the CPU, take advantage of the GPU, take advantage of the FPGA. And if done well and done correctly, you can take advantage of all of those things in a single hardware box or across multiple hardware boxes, just to really maximize your performance here. This is really a high performance computing solution, enabling you to maximize parallelism, maximize performance, and maximize efficiency, all while sticking to a standard-based cross-architectural language that you can influence, you can add to, that sort of thing. So we want to enhance productivity. Simple things should be simple to express. As I've watched data parallel C++ evolve from alpha to beta 10 where it's today, you can see that the lines of code to accelerate a particular function have gone from it almost wraps around two row lines to maybe just like a third of a row line. So there's been a lot of effort to make the code short, readable, understandable, and of course enhance performance. Give the programmer control of where the program can execute. Now it'll do its best guess for you, but you always have that option to say, well, no, I want this part of the function to execute over here and take advantage of some specific hardware feature. Like I said, it's fast moving. We're actually at beta 10. I think there might even be a couple of releases between now and Gold, with the goal of upstreaming everything that we've done to the C++ standards body and the Cronus group. So let's take a look at what a short DPC+ program might look like. Do I have a pointer? There we go. So it's single source, both host and offload device. So you'll see, if any of you are familiar with some kind of SYCL program, this will look very familiar to you. But in this case, this is a really small program here where we're just doing a little addition. So you've got namespace SYCL. You've got your main function. This is your host code right here, where you set up a queue. It doesn't really mention the fact, but you can choose your queue, and what that might mean is that where you actually execute the code has a default offload device, but in this case, so like on the dev cloud, the default offload device is a GPU, but you could choose, right? You could say, hey, I want it to be on a CPU. So this is actually just taking advantage of the default offload device. And then this is the accelerator code right here. This is what can be accelerated using a device, GPUs, FPGA, ASIC, whatever. And then, as you can see, it's just standard C++ loop here, and then it returns. So very familiar constructs to C++. How are we doing on questions on there? We getting any, or do I need to pause?
I think, Ben, that they are so interested that they can't even come up with a question. They are completely focused on what you're saying right now. So.
Okay, and I'm sorry if I'm talking too fast. I'm a little caffeinated, so I'll try and slow down a little bit. I know English may not be everyone's first language. So how can you take advantage of data parallel C++, understand what it offers for you with little to no effort on your part other than signing up for an Intel DevCloud account? So the Intel DevCloud for OneAPI is a development sandbox. It's quick to sign up right here. It just takes a sec. You get an account immediately. You get 4 months of free access. We've got Xeons in there, Gen 9 graphics, Gen 12 graphics. We'll have our upcoming Arctic Sound GPUs available to you. It's just a ton of awesome compute. I think you can have up to 2 gigabytes in your home directory We use the Torque PBS job system, and we maintain this diligently such that all you need to do is come in with an SSH client if that's where you're comfortable, or you can come in using Jupyter. I don't know if many of you are familiar with Jupyter, but it's a interpreter often used in Python that we've kind of modified to work with C++ by using magic cells. And so as you can see from the graphic here, you connect to a login node. And so that's something I want to point out. You don't want to do work on the login node unless you're using the Q subsystem. And so if you use the Q subsystem, you can target any device. You can say, hey, I want to target a GPU, I want to target an FPGA, I want to target a particular FPGA, or I want to target a particular CPU. That's all available. So if you guys are interested, and this will be required if you don't already have a DevCloud account, and you want to follow along with Adne here in a minute, sign up for DevCloud, and I'll leave this up here for a second. And what I want to say is, once you do this, make sure that you stay on the page and then look up to the right, and you'll see the word Connect, and it will open up a Jupyter Lab notebook for you. And but it will also send you an email, which will likely get targeted to your junk mail. It's going to come from Intel, and it gives you what's called a UUID, which is actually your password. So you're going to want to save that email because it's going to give you your user number, which is you, and then some 6-digit number, and then a UUID. And you'll use that for entering the information into a web page to connect. So the beautiful thing here is zero install. You don't need to update anything. We've got absolutely everything installed here, up to date, tested, validated, and you can come in and check out a whole bunch of Intel's latest hardware. So one of the features that Data Parallel C++ offers is the buffer model. So buffers encapsulate data in SYCL. They're a 1, 2, or 3-dimensional array that could be shared between a host and a device. Assessors access buffer data in the host or inside the kernel, and also communicate data dependencies between the application and different kernels. So if 2 kernels use the same buffer, the second kernel needs to wait for the completion of the first kernel to avoid race conditions. And you have all kinds of options here, right? It can be read-write, write-only, read-only. But what's interesting here, and what you'll see in a bunch of our sample code, is basically how a lot of the language shortening that's been going on. So the auto IDX, it's really simplified the language that accomplishes quite a bit here. So these assessors are the key mechanisms to access buffer data. So in this case, we set up the buffer, and then this is an accessor to access that data. And then this is our loop function. And then this is our handler for our queue right here that we will target to a particular device. So in this example, we've got int A, B, and C. We're going to set up 3 buffers. We're going to create a command group function object for the queue, and then we're going to submit, and this is a default handler, so we'll target the default by accelerator. In our case, it would be the GPU, and then we're going to allocate the memory using these accessor functions, and then do a lambda function, basically some addition. And so this is a function, fundamentally a DPC++ code anatomy. And you're going to see this over and over again. It'll start to look very familiar to you once you start playing around. Oh, there's a build. So there's creating the device queue. The buffers represent both host and device memory. I didn't mention that, but it's both. There's your submit command for your asynchronous execution. Once again, how do I get access to that data? You have to create assessors for accessing the buffer on both host and device. And then this is the execution function. And then you write the kernel out, which actually does the compute. and you get the copy of, the vector C at buffer C buffer, and then you get the destruction function. So I think for hands-on, we're going to do Audene's DPC++, or I don't know, depending on how we're doing on time, I can actually bring up the.
You have about 9 minutes, so
Okay.
if you have some more slides, by all means.
Well, so I think it goes hands-on right now. We can do the welcome IP and. Ooh.
Yeah, we can skip the hands-on if you want, and then I can make sure I touch on it.
Yeah. I think we're going to do yours instead of this one. So
that sounds good.
Yeah, because I want to make sure you have time for the hands-on. I want to make sure people have actually had time to sign up for the DevCloud, because
makes sense.
That's the good value there. So DPC++ has new features: unified shared memory, subgroups, and others. And the main goal of DPC++ is to simplify these programming languages and push these features back into the open source Kronos Group standard. Unified shared memory is one of the best new features. Enables sharing of memory between the host and device without explicit accessors and source code. So previously you used to have to manage your device memory, manage your host memory, and create that host device memory, and then remember to destroy that device memory. So what USM does is it simplifies the code process between host and device, and makes your management of memory allocation more manageable. It's actually not really very funny. Basically, making housekeeping of memory management more easy. So in this case, we're setting up unified shared memory. So you can see this in data, we're setting up malloc. We're initializing here on the host. The device can modify it, as you see right there. And then the host has the output. So we set up the memory on the host using universal shared memory. The device modified it, and then we're able to output the result. So there's some key things to understand about unified shared memory. It provides both explicit and implicit models for managing memory. So on a device, allocations and device memory explicit. Accessible on host, no. On device, yes. And so if you just take a look at this table, you can kind of get an idea how this works. So allocations and host memory, of course, both have access to it. And then when it's shared, implicit, both have access to it. So you can separate the job by using explicit data types. And there are reasons to do that for, maybe your offload device is way better, particular function than your host. So here's an example of an explicit data transfer. We're using a malloc device to move data between the host and device as required. So you can see we set up the malloc here. We're going to do a mem copy. And then this is the data device right here. And then we're basically moving the data between the host and the device as required. So does that make sense? So allocate the memory on device, copy the memory explicitly from host to the device, perform a function, modify the data, and then copy the memory from the device back to the host, and emit the ultimately emit the result. So this is malloc shared. Super easy to get the code running. You can see that both have access to the memory. We integrate the memory from the host here. This is the device memory. that has access to it and is performing operations on it, and then the compute. And so you can use these over and over again. It's pretty boilerplate, and this is basically how you get up and going quickly using universal shared memory. And with that, I think I'm going to pause for a second here and see if there's any questions, and then ask, does everyone have access to the Intel Dev Cloud? Because it would be great if you could follow along with Adne on this code walkthrough.
All right, thank you so much, Ben. So just a question from my side before moving to Adne. Can we repeat, because in the initial slides I've seen from you, if you can share it again. So this is a great toolkit that is available for developers in case of using, especially for this MEC Hackathon or for edge application developers. Can we see also emphasize again what can be the usage in terms of exploiting, for example, hardware acceleration, or can you give some examples of I don't know, like I mean, like computer vision or other tasks that can be very useful to be exploited at the edge?
I don't have a slide per se, but we do have some hands-on examples, and I just wanted to bring over. Hopefully, you guys are all on the Dev Cloud, and if you'll notice, you should be on a page that looks something like this. And what you'll want to do, rather avoid all of the SIGWIN and SSH stuff over here, and connect over here to Launch Jupyter Lab. And something I wanted to point out to you, where you can see a ton of examples along with Adne's code that he's going to show you here in a moment. And it takes about 30 seconds.
That's fantastic. Okay, good.
Yeah. I was working with someone yesterday. So I don't know if many of you are familiar with Jupyter Lab. You might have been familiar with it if you develop in Python or JavaScript or something like that. But when your account's created, now mine's going to have a whole bunch of stuff in it because I use mine all the time. A class called OneAPI Essentials is going to come in here. And a good place to start if you're unfamiliar with Jupyter is module 00. And I made a video here telling you how Jupyter Lab works. And this is kind of important to understand. Jupyter Lab is an interpreter. And you can do Python, Markdown, JavaScript, HTML, you name it, it'll interpret it all. But something key to understand is it's very linear. So in this example, we're using Magic Cell, and all we're effectively doing is writing out the C++ files and then shelling out in the background to execute on the standard, bash commands for compiling and building a project. So in this case, we've got just a super simple hello world, right? And what you want to do is you'll notice that the cell is highlighted with this blue bar. That means that's the cell that's active. And you want to hit play. And you'll see that there's a little star here and then a 1. So when the star's little asterisk is there, that means the cell is executing. And when you see a number in it, that means the number's done. So what we did is we basically wrote the file hello.cpp. Now we're going to submit it to our job queue. And that takes a second to execute because you are going out to a queue system. It gives you a little feedback module right here. And then as you can see, hello world was emitted in red. Now, let's say you needed to make some code changes. We can change this to say blue. So even though we've made changes, we need to re-execute that cell. So you'll see now that it says, okay, now it says 3 instead of 1. That means that cell's been executed. You can go ahead and resubmit the job out to the queue. And you'll notice that hopefully we get blue text out this time. And there you go. See, in a few seconds, you get hello world in blue. So that's kind of the use process of Jupyter through all of these exercises. And as you can see, we've got a one API intro, program structure, unified shared memory, subgroups, advisor, vTune, and then all of the function libraries available for you. So I think with that,
thank you.
I'm going to turn this over to Adine and have you guys get going. Adine, maybe I should just show them real quick how to get your material once it's in there.
That would be great, yes.
So a good thing to do is to go File, New, Terminal. So I already had a terminal up there, but there you go. And you're going to want to say CP data 1API _ workshop. What do we call it?
Huff transform.
Oh, that's right. Huff transform 1API note.zip. And right.
Yep.
So, and if you see that, there it is. And then the next thing to do is unzip. And you'll have a whole bunch of stuff inside your host. And then you can see right here on the left, it showed up. And you can open it up. And you can open up, I don't know, what notebook are you starting with?
Emulation.
Okay, emulation. And there you go. And then so now, yeah, that's it.
Thank
so
you.
I can't see if anyone's got questions, but we can go back.
Again, like I said, I think they are amazing listeners. So no questions yet.
So if you didn't sign up, go here, this web link right here.
Yep, and I posted that on the chat as well.
Oh, perfect. And then you'll go to this. You'll be at this website. And something else I wanted to show you guys just real quick while we're here. You actually can go to developer training modules if you happen to click on BaseKit. You can get an idea of each module and what's in there, and then do a direct link and it'll launch the Jupyter Notebook for you. So we've got both OpenMP offload basics, and we've got all of our introduction modules. So pretty cool site. Yeah. And I guess I got to turn this over to Adine, so I'm going to stop sharing. And please take it away.
Thank you so much, sir. I am trying to figure out how to share. So the share button is not clickable. Did you have the same issue?
Yeah, he made me a host or a presenter or something. So
okay.
Yeah, maybe.
Dario, do you want to show some love? Let's go.
Well, I think Mirko will give you the presenter rights, Adine.
Okay.
So that the share button will be available in a few seconds.
Sounds good. Mirko, you are my favorite from the get-go, I promise.
Yeah, you are.
Thank you so much, my good sir. Let's see. Perfect. Let me see if I can get rid of that. All right, let me know when you can see it.
Looks good.
Perfect.
Awesome. So I want to make sure I quickly highlight some of the things as to, before we delve into using one API on an FPGA, I think it's very important to also talk about high level. What exactly do you benefit from using an FPGA, right? So FPGA, one of the biggest value adds is, especially when you're thinking of it for using it for like offload acceleration, you know, you for instance, you come up with your, you know, you buy your servers, you buy your entire infrastructure, and now you're running a certain type of application on it. So now you want to offload part of that work to your FPGA. But then, you know, further down the line, you notice that, hey, like, I think I actually want to change a few things or run a whole different kind of application on it. Normally, you can't really completely reprogram on the fly as the thing is running, right? So FPGA, it stands for Field Programmable Gate Arrays. So the fact that it is programmable, the fact that you can actually design the hardware logic and write your own algorithm and embed it on the hardware
like silicon itself is one of the things that makes it extremely flexible and extremely appealing as well, even for offload acceleration. The other thing is FPGAs are really good at low latency, deterministic timing kind of situations. So what does that mean? So when you're dealing with extremely quick interaction either between your data source and your acceleration hardware, or your host and your acceleration hardware, or any kind of thing where you want to know down to like the nanosecond clock, how much milliseconds or nanoseconds will this algorithm take to be processed. That level of fine granularity you're not going to get from other architectures, but FPGA is really good at that, right? Because you know exactly what frequency it's going to be running on, you know how much area it's going to take on your FPGA, so the minute you embed it, you know it's going to take, from this region to that region, your data is going to be passing through this frequency, so you know exactly, you can convert that and say, it's going to take me this much amount of time. So being able to get that fine granularity of timing information is also really great. The other thing is when you have a bunch of tasks that are kicked off in parallel, but then you have interdependency between each loop, right? So let's think about like a for loop algorithm, for instance, that says x equals x minus 1. Now, in order to equate for x, you actually have to equate x minus 1 first, right? So those things, you can kick certain algorithms where you have interdependency across the different loop iterations. You can kick them off, in a parallel or like in a vector kind of format. Say you can vectorize it and run it in parallel, but since the result of one of the iteration is dependent on the other, you can't fully parallelize it, right? So you have to wait for one task to complete completely and then move the value over to the other task and then, put that as an input and then equate that. FPGAs are really great at handling these kind of situations. They are known for what we call a spatial architecture, where they use the space available in order to actually, save like smaller values into different registers and be able to get and read and write into different registers and be able to take advantage of things like pipelining. So these kind of specific niche workloads or kind of compression, decompression, like, zipping, gzip, or all these kind of use cases, FPGAs are actually a lot more performant. So, if you are doing these kind of things, and even in the machine learning world as well, FPGAs are starting to show a lot more dominance than different architectures. So, a lot more companies are actually starting to look into FPGAs as well to accelerate their machine learning workloads. So, just things to think about. And then we also have resources like the optimization guide that kind of talks a little bit about what are some of the things that I'm mentioning here to give you a little bit more context as well. So with that being said, let's actually get into, what does it mean to develop on one API using an FPGA? So the FPGA development lifecycle has, mainly we're going to focus on these 3 stages. Emulation and optimization, and then bitstream generation. So when I'm talking about emulation, this is basically, think of it as I'm basically compiling something like, a program on GCC and then just printing to the console and then seeing if the algorithm works. So at this point, I'm not actually, creating some binary or like, we call it bitstream. It's basically the high-level design language, in this case, data parallel C++, the application gets compiled into RTL, and then the RTL gets embedded on the FPGA. So at this level, we're not going through all of that, right? Because that process takes about a good 4 to 6 hours. But this is all running on your CPU. So it's extremely quick. It's literally being able to simulate the functionality of the FPGA. But then, if I am doing development, I don't really want to completely go through a full compilation and build it on an FPGA and run it every single time, because I'm quickly making iterations. I'm trying to see if, the little tweaks I'm making here and there are working. I'm trying to see if I have any syntax errors, all those small things, right? And so for a kind of this more software development, iterative approach kind of focus, the emulation stage is where we're going to, really take advantage of that functionality, right? And that's not really available in other FPGA development tools, like when you're running simulation and, synthesis in other simulation languages or RTL. It takes a while. So you're not going to be able to get this seconds level of granularity. And the function that we're picking is actually Huff transform. So this is it's a very common algorithm in computer vision application. And so basically, I bring up an image, run it through a Sobel filter, and now I've converted everything to black and white. And now I'm trying to do line detection. So I'm trying to see if, there is a line available or not. So the algorithm basically goes and converts a bunch of these different black and white and gray pixels into ones and zeros. And depending on, the density of the 1 and the 0, it can know, oh, okay, there's high probability that I probably have a line here. So, it doesn't do the inference. It actually does the conversion from, certain shades into ones and zeros. So that's what the Huff transform is known for. You can also look into it on YouTube as well. There's a bunch of really good videos that talk about what it does and how it connects to other filters as well. So we figured, you guys are going to really like this, so we picked that. Just to I'm going to quickly go over, I'm trying to see how to use, do I have a pointer? Annotate. Nope, you can't see it. Okay, never mind then. I was trying to be cool like Ben, but I guess I can't use pointers. Let me know if you can see my mouse. So you can see here that we are including, if you used C++ before, you've used vectors at some point. Fstream, it's a file stream library. And then we have Chrono, and these are specific to SYCL and OneAPI as well. And then, we're defining a few macros here for height and length of our buffers. We include namespace std and then namespace cl for, I believe that's SYCL. And so this is kind of where my main comes in. I create my input character arrays for pixels, and then I have an integer for accumulators. This is where I am storing my output, and then this is what is going to go and read my file. And then we initialize it, we fill it up with a bunch of zeros, and then we read our image and convert it into an array of pixels here. And then here, this is where we kind of start getting into our real data parallel C++ offload acceleration, code. So this is where we define what the property of our queue is going to be. So in the queue is where you're going to submit your, different kernel code or jobs. You have your SYCL range. Think of it as basically just a range. I guess if you've used Python like you do when you're iterating through a for loop, you use the range function. So I kind of think of it that way. This is our buffer. It's a SYCL way of defining a buffer, but ideally it works the same way. So you have a buffer with this size, and it's going to have these values as well. So you pass it the pointer of this pixel input array that we created and instantiated and filled up with with a bunch of pixels, I guess, from the image. And then you have your accumulator, and then you have your sine and cosine table information as well. So this is how your code decides. We talked about heterogeneous functions. So OneAPI, I can actually pick, I can pick a workload and say, hey, I want this workload to run on a GPU, I want this one to run on an FPGA, and I want this one to run on the CPU. So this is exactly how we take advantage of these things, by using our device selectors. So if FPGA emulator is defined when I'm compiling, then I want you to use an emulator device. If not, I want you to go ahead and run it on a CPU host, or I want you to go and pick an actual FPGA device. So this is how I pick what device I want it to run on. I've created my device queue, and we created the property list and how we want the device queue to operate. Do we want them to each queue to run sequentially, or do we want it to run in parallel? Is there any interdependency? This is where you define it, and then you pass it the device selector you want, and you instantiate it as such. Here, it's just printing extra information for a platform and the device name. And then here I have submitted my, this is where my submit function starts for, and when I submit my job into my queue. And then I pass in the handle. Here, you actually see the kernel code. And here, at this point, I'm getting into my device code. So here, this is my algorithm that's going to be iterating and running on the FPGA to get us, to convert these pixels into our results of ones and zeros based on some calculation that it does here. And then accessors, I know Ben talked about them as well. This is our way of, getting read-write capabilities based for certain buffers. So sometimes you're going to be able, as you can see here, I want my, FPGA to be able to read from these, global memory areas to read values, but I don't want my FPGA to write to these memory locations. So I create an accessor for just read. But then I do want this specific memory space to be written by the device that I'm accelerating. So I create a read-write accessor. So by using accessors, we basically enable the acceleration hardware to have the capability to be able to write or read from that memory space. And then, so I complete my task, and then I calculate the time it took, and then I report that here. And then here, we have a golden checklist, which is basically a file that we know has the correct values. We read that in, and we do a comparison. If it is within plus or minus 1 discrepancy of the values that we expect, then it's good. If not, then we report that it's failed. So ideally, once I compile, I'm waiting for this verification pass value. Oh, and then earlier we talked about read image. So read image, this is kind of what the function does. It basically inputs, it goes through and finds this BMP file and reads in the image as a series of pixels. So we run, so right now, just because the report file has a few issues on beta 10, I am converting it manually to beta 8 so that we run our whole thing on one API beta 8. But then by the time gold comes, everything's going to work. So I'm going to get rid of this as well. And so if you use that link to download the zip file, you should be able to access the latest one every single time. And then this is the flag for compiling for emulation on DPC++. Like I mentioned earlier, we have this check when we were selecting devices to say, hey, if this flag is set, I want you to simulate the FPGA and basically run it on the CPU. So that is what we're going to be taking advantage of as well. Let's see. This should take a few seconds for the most part. It's fairly quick. The kernel time, like I said, it's not really running on a real FPGA kernel, so it's just reporting whatever at this point. The device name, as you can see, it says FPGA emulation device, and then we have our platform name as well. So this is kind of our okay, the algorithm is functional. That we've attained that at least. There is a whole other portion where, you noticed here that some of the things our host was actually doing, some of the things the FPGA was processing, right? So you don't want to basically clog up all the logic into the same way, because now, let's say I changed the way I read my initial input image. Now, all of that side is actually being done on the host side, because once the host reads the image, changes it into like a stream of FPGA or like pixels, an array of pixels, then it actually sends it to the offload acceleration device in order to process those pixels, right? So technically, all of that side is on the host side of the code and not the device side. So if I'm making changes on the host side, technically it shouldn't take that long, because the host side, it's basically like compiling any other C++ language. But then the device side, once we've generated our binary and loaded it on the FPGA, it takes a long time to go through that whole full compilation every single time. So if I need to make a change on the host side, it would be advisable to have this split compilation, or fast recompile is what we call it. And there are some tutorials here as well available, so I would really recommend. It's on GitHub, so go check it out as well to understand more about this. So now if you divided, your host and your kernel, which I guess in this case is our device code, into separate files and compile them into separate objects and then just link them later on, then now if I need to make a change, I can just change my host code, recompile again the object file, and then link them again, right? So this is kind of how I would structure the code as well. As you can see, most of the things are not different. It's just now the kernel or the device gets called from an API instead, and the pixels and the output accumulators array gets passed in as a variable. And then, we do the same thing here. We create our ranges. We create our buffers for the set sizes. We create our devices, or our device selectors. And then we get into our device space where, in the kernel space here, I have the same algorithm as well, and I have the same accessors and reporting as well for platform. This is where I'm, recompiling again. I have a try catch for any kind of weird exceptions that might be happening. And then my host code looks like this. It instantiates my input and output arrays. It fills them up. It reads my image. It calls the offload acceleration API. Once it accelerates, it gets the value. It goes and opens up the golden check file, and then it compares and it reports whether it passed or not. So again, just dividing everything into its respective piece and compiling them separately. As you can see here as well, I'm compiling my main and my kernel separately into objects and then running it as an emulation as well. And you can see that I got the same verification pass, which means those two codes are functionally equivalent. Being able to get to this in a matter of seconds is a giant value add, because normally, like I said, FPGA compilation takes a while. So kind of just to go ahead quick, please feel free to stop me, ask questions. I'll try to make sure that I answer them. So now I have done emulation, but now, okay, I know that my code is functional, but how do I confirm that it is running optimally as well? So let me see. Let me see if I could do that. Okay. So I need to make sure that it is running optimally on the FPGA. It is performant. It doesn't have any bottlenecks as well when passing information and data from from device code or from host all the way to the device. So that means I need to actually generate a report file and look at, does it have any bottlenecks? What does the performance look like? What is the timing? All that good stuff, right? And so we do that by compiling, by compiling a report file and being able to view that. So a report file kind of looks like this. You have your throughput analysis, which gives you information as to, when you're doing, and it's actually connected as well. So it tells you which part of the code it's looking at. So it has concepts like, is it pipelined or not? II means initiation interval, which is basically the number of clock cycles between, different iterations in your for loop, I guess. How many clock cycles does it take before I get to x equals 0 and x equals 1? And if you have a lot of clock cycles, ideally you want to attain 1. So as you can see, our logic right now is extremely inefficient. So we're looking at close to 464 IIs to get to the next clock cycle. So we definitely need to fix that. And it's pointing you to the part of the logic that is causing you that. Fmax is basically the maximum frequency. Latency is, again, it's the inverse of Fmax. So instead of frequency, now you're measuring it in time. So like how fast or slow is your algorithm? So it's extremely slow, as you can see as well. You can also look at different things, area analysis to kind of see, what does your kernel and your host code look like? How much area is it taking? What else? Memory analysis to kind of see, okay, how many registers are available? What does the memory output, or like the memory architecture looks like? Because FPGAs, you have on-chip memory, which is extremely fast, but depending on how you choose to use it, it can be a bottleneck for you, or it can be a way to optimize your code as well. So it's definitely important to make sure you look at your memory architecture and say, and look at, are there any opportunities to remove any bottlenecks as well? So the first optimization that we're going to do is called kernel args. So this is essentially saying, hey, it's kind of like the restrict keyword in C++. So if you have, it's the compiler is not going to optimize your code very aggressively if it knows, for instance, we passed in these variables, but it actually doesn't know if these two pointers are pointing to the same, if they're pointer aliased or not. So when it's a little bit ambiguous for the compiler to optimize, it chooses not to optimize aggressively because, it might be a case where, maybe, okay, they were pointer aliased, and at some point they did point to the same location. Now I'm going to run into some memory seg faults or some form of issue that is going to be a lot more serious. So instead, I'm just going to keep them as is. So by doing kernel args restrict here, I'm saying as a developer, I know that they are not memory aliased. So go ahead, do as much optimization as you want. These pointers don't even point to any, identical memory space. So I literally just added that line, and I'm going to compile it here. It says the compile finished. Let me know, can you see this actually?
Yeah, I can see your screen.
Okay. Yeah, do you see this image here?
Yes.
Okay, so you can see my II went down from 464 to 233 by just enabling my compiler to optimize aggressively. So I didn't really do anything at that point. I just, enabled it and said that there's no memory or pointer aliasing. The second one is called local memory, which in this case, where, every time it's iterating from, every time it is doing this compute, it's always going to global memory and grabbing it using the accessors and then compiling. And then every single iteration of my for loop, it's actually going out to global memory and grabbing the data from like DDR memory or something, right? So like I mentioned, FPGAs have on-chip memory, which is a lot faster. So what I'm doing here is instead of every time reaching out to global memory, I'm going to go and actually go through all the data that I want and load it to my on-chip memory, do my computation on my on-chip memory, and then store it back into my global memory from my on-chip memory. So being able to do that, you can see here my II went down from 233 to now it's at 2. So it's a huge memory gain because at this point the compiler knows what part of the memory it's operating on, so it can optimize the loop and do a lot of pipelining, and it can also just optimize the memory structure or the memory architecture as well to be a lot faster. And then unroll. Think of unroll as basically now, and for this for loop design, instead of having one of these, now I have 32 of them all running at the same time. So that's kind of like a very high-level, quick explanation. I'm sorry, I only have 2 minutes, so I'm trying to make sure I go fast. So unroll basically, yeah. So it's basically like you roll a bunch of these for loop designs or loops or algorithm multiple times and vectorize it, and then basically run them at the same time. Of course, you're going to follow pipelining and whatnot. So by being able to do this, at this point, I expect that my II is going to go down to 1. And as you can see, it went down from 2 all the way to 1. So at this point, I have reached my maximum initial interval. This is performance for throughput. It is, it is killing the game. Banking, like I mentioned, on-chip memory, it is the FPGA memory, and you can architect it and structure it however way you want. So what a bank does is instead of having this giant lump of memory, you can actually break it down into smaller chunks of memory. And, basically now instead of having this one giant memory block, I have 2 of them, and I can do I/O at the same time. So I have independently operating input-output ports, and I can have multiple of these. And now that means if I used to go and read and write to my memory, using one port, now I can have 2 of them that are operating in different memory spaces. So that is how it works. Dario, it's 10 on my time. Can I still finish up on bitstream compilation, or what's your time looking like?
Yeah, I think we have just the time to summarize. And thanks so much, Adonai, for this presentation. So I remind everyone, so the recording will be made available for future watching for everybody, and also we will publish also the slides and the material afterwards so that people can read the material and appreciate all the details. Let me also give a comment here before moving to the next speaker today, and emphasize that we already have some FPGA cards provided the venue for the Cisco servers at the venue. So actually this is a great offer that we have installed, that there's FPGA cards and also available with one API. So let's also emphasize these aspects. So the environment is really integrating as well the FPGA cards with one APIs, and so here is the reason why we are presenting this nice toolkit, because of course, as you said before, Adonai, there can be the opportunity to exploit some task acceleration, and that at the edge can be beneficial to build applications that maybe are delay critical, or maybe exploiting some complex tasks, as you mentioned, computer vision or deep learning, or any kind of other task that may require even pipelining, as you mentioned it, right?
Yep, absolutely. Yep, embedded workloads are amazing on FPGA, so definitely take advantage of it, look into it.
Sure. So let's say this is the first time that we are providing all this stuff together in a MEC environment with the openness and with one API and with real servers also remotely in a fully remote event. So I cannot imagine what else we can do, what more we can do in the future, and we can see maybe nice and amazing applications from developers that can use even more. There's all these toolkits. Thank you so much, Adonai. Thank you.
All right.
Thank you so much. So actually, we don't have any more time for questions, and sorry for that. But I think now it's time to move to the next speaker. And let's have a quantum leap from very detailed technically aspects and quite amazing also topics about one API and FPGA cards. So very, very detailed. And now we intentionally wanted also to include in this agenda for the hackathon also equally important a very nice keynote speech from Martin Olsik from Techstars. Sorry, maybe the surname I didn't.
No, it's perfect. It's a difficult one.
Okay.
Very good.
Thank you. Thank you for your kindness. So thank you, Martin, for being here. And also, we invited you because, of course, for many reasons. One is because you will explain better Techstars as recently a footprint as well in the Turin City, which is the entity which is having the patronage of this MEC Hackathon, initially planned for face-to-face, now all virtual, but yeah, this is the thing. And also because you are an expert on talking with the developers, startups, innovators, and I think it's equally important not to focus only on the technical details, but also business meaningful discussions and more, let's say, high-level topics that you are covering in your keynote. I don't want to, let's say, disclose too much, but up to you. And thanks again for being here in this hackathon edition. Thanks.
Yeah, thank you. Thank you very much, Dario. Thanks for inviting me. Thanks for having me, indeed. My presentation will be way more top level and non-technical at all. So I will talk more about how we support companies and developers, entrepreneurs in creating companies in Turin, but also globally. And of course, what we see so far in terms of 5G, this was my headline for the presentation. So Dario, please help me if you can see my screen, because I'm getting an error here.
Yes, I can see it.
Okay, well, perfect. Then, yeah, welcome everyone. My name is Martin Olczyk, as Dario already said. It's a Polish name. I was born and raised in Poland before moving to Germany when I was 10. Started studying in Germany, created a few companies there, sold one company. So I would call myself an entrepreneur at full heart and full blood. And once I sold my business and decided to invest in companies as an angel, supporting founders across the globe, I became a professional investor 2 years ago with Techstars. Let me give you a few slides here on Techstars, who we are and how we work, how we invest. You see I'm not familiar with WebEx, but I think it works. So yeah, Techstars is a global organization headquartered in Boulder, Colorado, US, and we started in 2006 with a simple idea and a simple assumption, and we thought that entrepreneurs create the future, and collaboration drives innovation, and great ideas can come from anywhere. So we're not very stick to Silicon Valley, and today the mission is very similar, right? So we think that innovation should be accessible to everyone from everywhere. People shouldn't have disadvantages because of locations. So what we do is we connect startups, investors, entrepreneurs, corporates with cities to create a more sustainable and more inclusive world by entrepreneurship. And yeah, we do that. I will talk in a second, like how we invest, how we create it. But we do not only invest in companies; we really empower communities globally. So some of you might have heard of Startup Weekend, Startup Week, where we really bring early stage entrepreneurs together from schools, from universities, people who are interested in building companies, in creating technology players. And this is something which we do especially for empowering entrepreneurship, but this is not only for fun, right? So we have seen companies being formed over this hackathons, 54 hours over the weekend at the Startup Weekend, where we bring people randomly together. We help them with coaching and give them advice. And we see companies emerging out of those Startup Weekends. So after 54 hours, we had first MVPs, of course, but over the time, we see, for example, a company at the Techstars portfolio, which is a unicorn today, which was born at such a Startup Weekend. So this is a highly recommended initiative. Shouldn't never attend one of those, please do that. We do many events across the globe, 1,500 a year. We also have entrepreneurs toolkits on the website, so we help people who are more technical, who are not very familiar with business, with economics. We help guiding you through the first stage, how to start a company, how to hire a team, how to build sales, how to grow, how to sell, and how to get funding from investors. So I'm very interested in really bringing people to the kind of knowledge pool which we offer. And my program is an accelerator, so I'm investing in 10 to 12 companies a year. We do that on a global scale. I will come to that in a second. And we invest early stage, means like we also invested already in teams with a product, with an idea, and not only looking at mature companies. And we are investing early, which means that we hopefully bring companies from early stage and early days to IPO. So as I mentioned, we have now 46 of those programs running globally. Our majority is still in the US. I'm running my program here in Turin in Italy, but we also have locations in Europe, from Abu Dhabi over Amsterdam, Berlin, London, and Oslo, Paris, Tel Aviv. So if you're interested in one of those, happy to give you more details. Feel free to connect with me. We also have Anywhere, which is a purely online program, which means that we run all the activities without being there in presence. For now, due to the pandemic, all our accelerator programs are running fully virtually. Hopefully that changes again next year. Let's see. You see we are truly global, so this is not only the program locations, but also Startup Week and Startup Weeks we've run. So we really try to get people from all over the world together and help them by building a community. Started in 2006-07 with the first program with Microsoft, Barclays, Disney, Nike, and evolving into also new products. So we also not help only startups, but also large corporates and the cities, empowering entrepreneurship, supporting really what we do here in Turin, the government working with large corporations and bringing more entrepreneurship, more knowledge from all over the world to build better companies. Yeah, a few words on the programs. So as I mentioned, we invest in roughly 500 companies a year now. Those companies who get investment from us join us for the 13 weeks. We help them with mentorship. We help them with access with best practices. Each startup receives 120,000 USD, the first investment. And after that, we are also capable of investing in Series A or Series B rounds. Today, we've run more than 240 programs. Companies raised more than 10 billion USD in funding with a market cap of 30 billion. And for those who are familiar with Crunchbase, this is a kind of a funding investor startup site which lists all funding, reports all fundings and activities within the startup environment. We are the largest investor by volume there. So our founders are in a good company. As I mentioned, we do roughly 500 investments a year only during this accelerator phase. We have more than 2,000 today, 300 companies already. Many founders, we bring founders together once a year in several locations. Last year in Turin. The year before we went to San Francisco. So we are really trying to build a community and bringing and learning from each other especially. There's a great number which we're super proud of. So 84% of our companies is still active or have been acquired. If you ever build a startup, you know how difficult it is to survive. So especially our mentors are those who are responsible for helping the companies and staying successful, growing, and becoming unicorns one day, hopefully. So this is the network which we provide here. So more than 15,000 active investors in our network. We have roughly 8,000 mentors who are supporting the company, more than 100 large corporates. So those who are really working and investing and helping startups becoming bigger. This is how it works. As I mentioned, we select 10 to 12 companies per program, bring them together for 13 weeks. And we always say we condense 2 years of work into 13 weeks. So it's a super high intense phase for every founder. And but it's also a lot of fun and many learnings. And we also, you see those people in the picture here. There are many, many funny moments as well. What do we do in Turin? Very similar to what I mentioned. We run the program here from January to April. We invest in 12 companies from all over the world. We provide access to local mentors, but also global mentors. We have 3 corporate partners here with us. So we have Compagnia di San Paolo, Fondazione CRT, and Intesa San Paolo Innovation Center, who are providing our startups with access to their networks, with mentors, with support to Italian, but also international industry. And we provide also perks for each startup. So we have currently more than 300 perk providers with perks valued more than 5 million USD. So Amazon credits, Microsoft. Not sure if Intel is providing one, I have to check, but many companies who are really supporting startups in the early and first days of incubation. We run this in this beautiful location. If you haven't been there yet, OGR, Cine Grandi Riparazioni, our location. So once the program goes back to in-person, so on the left side, you see Talent Garden, which is the office space. In the middle, we have 4 nice restaurants. On the right side is our large event location where our demo is supposed to happen. Shouldn't you have been there? Happy to invite you. Demo day will be end of April, hopefully in person. And what do we provide? And this is where I promise. Firstly, start talking about 5G. We not only provide the Techstars network here, right? So Turin is moving into a smarter city year by year. I joined and moved to Turin last year. So many things happen there. We have a lot of industry players, of course, familiar for everyone, probably FCA, Fiat Chrysler Automobiles. We have many investors, early stage one like Club degli Investitori, who is investing in early stage companies, mainly via business angels. We have other incubators like i3P. We have later stage venture companies like Neva from Intesa San Paolo as well. Our partners, as I mentioned, are providing a lot of input, a lot of feedback and support for the companies. But we also have other initiatives, and this is which makes Turin very interesting in my opinion. So before running the program here in Turin, I was running the accelerators for Techstars in Amsterdam and Berlin. And for me, this is a very, very unique and special environment for every founder who is joining us. So we work together with the Torino City Lab, which is providing 35 kilometers of autonomous roads for autonomous vehicles. We have drone testing environments. We get access to the infrastructure, like traffic management, for example. We have roughly 70 large corporates there, like Iran and many others, who are looking into innovation, who are eager to work with startups. We have a 5G testing environment. So this is something which is very special. So our companies get already access to 5G across the city. They can test drones. They can test their autonomous vehicles there, supported by 5G. And this is where we really see the difference comparing to LTE 4G, where 5G comes to play. And let me talk about a few benefits, what we have seen so far. So as I mentioned, my presentation knowledge is not very technical, but I can just report back what our companies are experiencing by working with 5G now. And as I mentioned, like very early stage, but everyone knows, and you know better than I do, so the 5G network is way more faster. It allows many more connections. In our case, looking at the smart city, very, very important. It's more energy efficient and, of course, more reliable, right? So if you imagine the use cases, healthcare, autonomous driving, autonomous drones, very, very important, and it opens up so many new possibilities which were not possible before. So especially in our industry, as I mentioned, like smart driving is something which we see now with via testing in Turin, via testing in other environments. It's a new game for everyone. So we have several companies working in this environment already. This will become, I think, a game changer for every autonomous car in the future. We see smart cities, many sensors who are not able to report on time or not enough data on 4G. They are now opening up new possibilities. AR, VR, definitely also tests and environments for 5G capabilities. So really great solutions. I'm talking to founders every day from all over the world, and everyone who is working in that field is super excited about it. Of course, Industry 4.0, remote machinery operation, something which we see growing and growing way more. I just talked to a large company today, global player as well, who is now also testing 5G capabilities by predicting maintenance of their machines. And of course, healthcare, right? So wearables, all this monitoring, which has to be very reliable, which has to be on time, and real, for example, like monitoring your heart, whatever. So it's our life at the end. So we have to have very reliable and transparent and fast data. I think we are all at the beginning, right? So 5G is not deployed yet, but there are many studies. This is from McKinsey here. So there are many opportunities to start working in 5G. We see, of course, Industry 4.0, although related to our study, which we are looking at the market, will be something which will grow exponentially over the next 5 to 10 years. Smart cities, smart energy as well, connected offices. We now work in a different environment, in a different world after COVID, and connected health is a big opportunity for everyone as well. Today is definitely day zero. So looking at a different forecasts, I took this one from McKinsey because I think this is a great one showing like why we should start today, right? We look in the next 5 to 10 years, the opportunities are exponentially growing here across all industries. And that's it. So if you're working in 5G, if you're interested in joining our accelerator or any other incubator or working on your idea, happy to chat and ping pong back ideas. I think if you are like coming back to the presentation before me, technical person, I'm happy to help on the economical side as well. Happy to introduce the right people who are working more on the business side. And I can just say, like, as a former entrepreneur myself, keep on going. I think entrepreneurship is a very exciting part of the journey, and technology is evolving so fast, and I'm super excited personally about what will happen in 5G over the next 10 years. Very open for any questions. We have 10 minutes left, so Dario, I'm not sure if there are any questions in the Q&A. Otherwise, also feel free to connect me on LinkedIn. Happy to chat there.
Thank you so much, Martin. Yeah, actually, no, I don't see questions. I have maybe a comment from my side. It's very amazing what you have done in so little time in this organization, and also very well connected with the industry. My comment, it's more like a wish actually. So it's that. You are here invited for this hackathon, which is actually not the first edition. My wish would be that this can be just as an appetizer for future collaboration. I see a joint interest in attracting developers, and all the use cases that you are mentioning here in the different verticals are really key for edge computing. So my feeling is also that, let's say, with this kind of events like MEC hackathons, we are attracting edge developers and all the ecosystem of application developers using edge. The aim is that maybe in the future we can also further collaborate, and this can be also beneficial for you if you are, let's say, hunting for talents. We can do our joint effort to attract developers using edge computing technologies, as we are doing every year. Okay.
Absolutely. Happy to come back next year, hopefully in person in Turin, at OGR or wherever.
Sure. And let's see also the outcome of this hackathon in the celebration day, and what can be also the follow-up, because as I said this morning, one of the prizes is also offered by the Turin City as an opportunity to be selected and participate to the Smart Road project. So let's see what will happen. And thank you again for your presentation. Let me open the floor for questions in case before closing this part, and thank you again.
Thanks for having me.
So, okay. So if there are no any further questions, I will ask Mirko to give me the presenter ball just to present the status. And thanks also again, Martin, for your nice and great talk today. So this is now the time to just make a recap of the afternoon. Let me also share again my screen because I wanted to summarize this. The slide that I projected this morning on the agenda for today. This is as usual, we organize in 2 tracks, and now we ended the afternoon session with the presenters and all the keynote speakers. We are still waiting at 5 o'clock the delivery, the intermediate delivery from developers. And so now we foresee just a coffee break. So we will end the track number 1. No more keynote speakers here in the public event. We will reconvene in a private room with the elevator pitch for developers, where they will present us their first intermediate delivery of their project. And then, of course, this will end the day 1. Let me also anticipate again what will happen tomorrow. We will reconvene again at 10:30. And please notice that the WebEx link will be different for the day number 2. And this will be again as a sort of online conference organized as well as today. So tomorrow we will have a lot of keynote speakers, and not only from a technical but also from a business side, very interesting. All of them, I will encourage you to follow all the day, and also at the end of the day there will be keynotes and final panel discussion. It's a pity that, Martin, you cannot be there. You already told me. We invited you to be also in the final panel, but yeah, next time. So this is okay, cool. Fantastic. So let me now thank you again, everybody. If there are any other questions, otherwise, let me stop sharing and simply now here still without a microphone, but still available for 5 minutes. Please, Martin, stay connected, please, for the 5 minutes in case of questions until 4:30. And then we will make our break while waiting for the final intermediate delivery from the developers. Thank you so much, everybody.